Well, hello everyone, and welcome to Global Azure Norway. My name is Henrik, and I am part of the Norwegian .NET user group who are organizing this event, and I'll be your host for this session. If you have any questions during the talk, please use the chat to post questions, and I'll include them in the Q&A session after the talk. With us here now is our first speaker for tonight, Alexander Slotte. Thanks for joining us, Alexander. The screen is yours.
Thank you very much, and thank you for being here and joining me for this talk today. I'm super excited to be here. Thank you for inviting me, and I'm going to start off this conference, which is a great honor, and talking about a year-long migration here from .NET Framework to .NET Core for a large enterprise application that I was working with a whole team around, which is great. So a bit about myself first. I am Swedish, but I'm living in the United States as of 5 years ago, and I'm a Microsoft MVP in developer technologies. A lot of my free time is spent on machine learning, especially in .NET, and there's actually a conference coming up in just a month's time that focuses on ML.NET, which is the open source library around machine learning in .NET. So if you're curious about learning more about that later, definitely join our Slack channel or sign up for the conference, and we'd love to have you there. But today, we're talking more about .NET Framework to .NET Core. And I want to take you on a journey throughout this year-long period on where we started, what we did, and where we landed. Because a lot of the time right now, going to .NET Core is not so trivial as one may think. There's a lot of complexities when you start thinking about a large enterprise application that there's not so much documentation on, really. There's a lot of documentation on simpler transformations and simpler stuff, but when you start thinking about things with multiple external dependencies and services and old code and so forth, it gets very tricky really quickly. So I hope that this is going to be beneficial for you. And if you have any questions throughout the presentation, feel free to add them at the end. But we'll start off by talking a bit about the application we're migrating and the organization we're working with. And then we'll focus more about the actual kind of work we did to get there and what kind of strategy and tactics and steps worked for us. And then we'll kind of wrap it up and think about what were our lessons learned and what we could have done differently if we had done it today. So to start off, let's look at the application. So the app is a very standard .NET Framework app. It's a large monolith with 20 projects of varying sizes. It has a lot of old dependencies, so a lot of NNUG packages that haven't been updated for years and years and years. We'll see that later in this talk as well. And the frontend is an AngularJS and Knockout.js frontend, so it's not necessarily web forms or anything like that, but it's just a plain old JavaScript framework on top. But this application is a very large and important application for this organization, and it's connected with multiple dependencies. So they have a lot of external applications that are calling this app, either through message services like RabbitMQ, or through Node.js Glue applications, or directly through the API, or through something like BizTalk. So it is highly, highly connected in this interweaved web of applications. So any change to it is kind of detrimental to some extent to anything else. So we had to be really, really careful here not to break anything. But the app itself is fairly plain .NET Framework, complicated application, but just a lot of old stuff there. If you look at the organization that I was working with here, it's something I call waterfall agile. They were working in smaller Scrum teams with 2-week sprints, but the organization itself was still very waterfall-y. It had multi-year products, for example, re-ramping a whole data architecture layer for something that we planned out multiple years in advance, adding a completely new revenue stream to the project, and that's planned out for 2-3 years ahead of time, and there was no way you could change those project plans. So we had to really kind of work our way around those kind of waterfall style things as part of this migration. And we had to also be very careful not breaking anything, because if we broke anything, the client would be very sad, because this was a financial application where numbers were really important, and we didn't want to, in this case, pay out the wrong amount of money to certain individuals. Another struggle I would say with this organization was that they didn't have a culture of staying up with the latest. So a lot of times, going up to the next version of a NuGet package or trying out a tool or anything like that was very difficult. They were necessarily wanting us to do that so much as focusing on just creating new features and not realizing that technical depth builds up over time, and then suddenly that can tip the ship. But the team was fantastic, and one of the really good things with this team was that they focused a lot on mature quality practices. So a lot of automated testing was in place, a lot of work was put in place to kind of get that value across the whole team, and that really saved us, and I'll show more about that in a bit. So how do we get buy-in to do something like this, something as large as a 1-year migration from an old framework to new? Well, we had multiple failed attempts over the years to try to get this up and running. So to give some context, this organization hosts everything on-prem in IaaS. And one of their goals for the new CIO is to move to the cloud, to AWS, to Kubernetes in containers. And as you may know, it's very difficult to run .NET Framework in a container. You can do it, of course, but it's expensive because they're large images and it's bulky and it's not as nice. So you really need to go to .NET Core to be able to run in Linux containers, just do it much smaller, much faster. So for us, that was really the tipping point when they really went for the Kubernetes container path. This was something they had to do. But we also focused a lot of our efforts on talking about security and talking about how outdated dependencies can really halter your security practices. No client or no company wants to be in the news because they leaked all their important data and all the important information. And having a discussion around security and how about staying up to the latest really helps you with that. Just as you do patching on your servers, you also need to make sure you patch your software, so to speak. But another thing as well to talk about with your teams when you want to do something like this is about the expected, extended life expectancy of an application. If you do something like this, you can probably at least expect 5 more years of application, because suddenly you're up and running something that has smaller footprint in terms of memory and CPU, as well as just getting more up to date on the latest packages. So that was basically kind of the context about the application and the organization. But let's focus a bit on our strategy here. So we started off doing this about a year ago in February 2020, just before the pandemic kind of hit. And we had really no experience with .NET Core. We were all enterprise .NET Framework application developers, and we had no idea where to start. But we set up a couple of kind of cornerstones here that we wanted to follow. And the most important one that I think was really helpful for us was that we did not want to plan and analyze everything up front. We wanted to stay agile and incremental. So we wanted to avoid getting paralyzed by analysis. And we also want to make sure we didn't have a long-running branch. We don't want to kind of start branching off applications saying, this is our old application, this is our new application. We did not want to do that. And the reason for that is because the business really needed to have features being delivered continuously. We couldn't stop doing what we were doing, having a feature freeze. We still needed to provide new functionality to the business. One way of doing this is that we actually dedicated 1 to 2 developers in our team, focused on leading this effort and doing that kind of spearheading and analysis, and then spending about 20% of our sprint time and sprint allocation on this migration with the larger team as well involved. And I think that was a great tactic, and I would kind of encourage people to think about that if that's something that works for you. Before we jump into kind of how we did this and what challenges we faced, I would like to say that some of the key success factors for us was that we had a very mature quality culture across the team. We use something called behavior-driven development for our testing, and we wrote a lot of our tests in Gherkin syntax, so functional tests from the API and the UI level. And I really recommend you to think about ramping up your automated testing if you haven't already, and especially on terms of your functional test and UI test. We will see later that unit tests are great for a lot of things, but not for this scenario, because unit test doesn't really check the framework kind of application functionality that we will need here. I also want to kind of really push for my last point here, which is have a fearless approach on technical debt here, or cleaning up stuff. When you start going down this rabbit hole of migrating a large app to .NET Core, you'll find a lot of stuff in your project files and your solution files. And they're going to be dirty. They're going to have things you have no idea what's about. They're going to have things that doesn't make any sense. You may, well, is this actually used anymore? And a lot of times they're not. A lot of times it's going to cost you a lot more to move that to .NET Core than you have to remove it. So I would just have the approach of like, remove it first and ask for forgiveness later. And if you have a solid testing framework, then you will be able to kind of lean on that to find things that you expect to work a certain way. So definitely try to clean up as much as you can. All right, so moving on here to our journey. What did we do to get to the final product here, which actually went to production, I think 2 months ago now, after years of work? Well, the first thing we did was, like any good developer, we Googled things. So we started with Microsoft Docs because that's a good starting point. And I think, the docs in Microsoft are really, really great overall. And there's 2 documentation sites here for how you port something over from Framework to .NET Core. And they're both equally good. One is focused more on the web stuff, and one is focused more generally. I would say, like, yep, go ahead and read these. There's a great starting point for everything. But there are, there's a reason why there's 7 minutes to read and not like a month, right? It's because it's very general. It's not going to cover your specific scenarios that you're running into or your specific application, but it's going to give you at least a starting point to understand what the big building blocks to move your application are. The documentation also suggests that you download and use the .NET Portability Analyzer, which basically is a right-click in your solution, and Visual Studio will generate an Excel list of thousands of things that are incompatible for you, so you can work them away. We did that, and I have other kind of peers in the industry that done as well. But it is not very helpful because it's overwhelming the amount of things you need to fix, and it's not very structured. So you don't really know what is caused by or how you can alleviate that. You just end up with a long list of things that you just, I don't know what to do about this, and you get overwhelmed. So I would just avoid that for now, and I would focus more on the big stuff, and we'll walk through some of them here in this presentation today to see how you can get that result anyhow. So this diagram here kind of outlines the steps we have to take to get to our place. For example, we had a lot of different things that we have to do here. And the red things is things that I want to talk about first. So we have no WCF services, and we had no web forms application. It is something that is just important to think about, because a lot of times when you migrate applications over to .NET Core, you actually have those kind of applications or services, and they are much more complicated to migrate than anything else. We consumed WCF services, which is very different than actually hosting them, a lot easier. But if you do have any of these constraints in your application, which is very likely, there are ways to resolve them. And I'm going to point you to the documentation for WCF services, and maybe thinking about going over to gRPC if you can. And I would also think for web forms, I would look at Jeff Fritz, who is a fantastic product manager at Microsoft, and he's done a lot of work on Blazor components, basically being able to kind of port web forms straight to Blazor. So if you have those constraints, have a look at those resources. Also happy to chat more about them separately in questions or later, because I do have a lot of industry peers that have faced these challenges, and they have some great insight in those as well. But we'll focus on a green diagram here today and kind of guide you through that. So let's start off with the first one here, which is upgrading and targeting our application to .NET 4.7.2 and see what that really means. So the first thing I always recommend teams doing is going up from 4.6.2 or 4.5.2 or wherever you're at to 4.7.2. I do not recommend you going to 4.8 actually, but 4.7.2 is fine. And the reason why you want to go to 4.7.2 is because 4.7.2 and .NET Core 3.1 have a very similar kind of API target area, and they both share that through .NET Standard 2.0. And that basically means that there's a lot of things in .NET 4.7.2 and .NET 3.1 that are shared in .NET Standard, but then you'll have certain things in .NET 4.7.2 that does not exist in .NET Standard, and vice versa with .NET Core. But it's a great way to get as close to .NET Core as possible. Because if you do that, you can basically start targeting .NET Standard 2.0, which is what we want. The reason why you don't need to go to 4.8 is because 4.8 doesn't get you closer to 3.1, and actually just causes more issues. So don't go to 4.8 if you don't have to. So once you're at .NET 4.7.2, which can take a while to get to, because you will get some assembly reference issues and redirect issues. After that, what you want to do is you want to go ahead and migrate your project files or your package.config file to package references. So if you remember how things are right now, you will have a long list of dependencies in your package.config file for your NNUG files. But that's in .NET Core 3.1 and 5 and forward. That's going to be a package reference in your CS project file instead. And there's actually really easy to do this. You just right-click on your product, and you automatically be able to migrate that to package references. And the final thing you want to do as well on this stage here is that you want to convert all your products to SDK product style, which is just easier, much cleaner. And the good thing with this SDK product style is that it's tied to Visual Studio 2019 and not to .NET Framework or .NET Core. So you can do that really anytime you want to. But it gives you a much cleaner project file. You can double click on it and you can open it and view it. And it also doesn't include like defining all the classes that you have in your product. It just by magic, it will just use any class in your directory of your product, and it will have that as part of your compilation. So for example, we have this old package.config. We will kind of remove this. We won't have this target framework 4.7.2 and all this kind of stuff. Instead, we'll go to this SDK product style version instead, where you have this item group with package references in the middle. And you also have an item group for product references. And you have a very neat and clean description of what we're targeting and so forth here. But what you're missing here, right, is you don't see like include class 1, class 2, class 3, because that's not needed anymore. So that's really nice. So once you're on target 4.7.2 here, which could take a while, depending on how many products you have and kind of what challenges you run into here, you want to start looking at the configuration instead. So what do I mean with this? Well, currently you may be using the web config for your configuration values, right? And this is an XML-based config, and you have transforms for different kind of scenarios, test and stage, and they're just like that. In .NET Core, you have a JSON-based configuration instead. We have app settings on JSON, and then you can have transformations as well if you like, for like .test or .stage or whatever you want to. So you need to start kind of moving over from A to B here. And you can do this before you start targeting .NET Core as well in your projects, just so you know. And this is kind of the beauty of it. And what we need to do here is actually start slowly migrating our providers over to this new format. I'll walk you through the steps, but I just want to highlight that I've written a blog post about this. So it's kind of in depth and it's kind of complicated sometimes on how you want to kind of migrate the configuration over. So if you want to read more about this and have more in detail, you can find it on my blog. It's just alexanders.com, and I think it's one of the first ones still. So definitely have a look at that if you want more detail. Hopefully it's going to be helpful for you. But basically, what you want to do here is you want to get to a state where you can have a web config and app settings JSON side by side for your application for a little bit. So basically, you need to be able to read both at the same time while you slowly migrate over your app setting values to app settings.json. If you have 10 values, you don't need to do that because you can just go straight over. It's all done. But most enterprise apps have a lot of configurations for good and bad, and it will take a bit of time to move them over slowly, as well as in tandem, upgrade your CI/CD tools for overriding those values, for example. And the way you do that is you create a custom provider. Basically, it's a custom provider. It's a small little class that just reads both the web config as well as absence JSONs together. And once you've done that, you basically can use that provider to create an iConfiguration. And an iConfiguration is an interface that you get from the Microsoft.extensions.configuration NUG package, which is the new way you do configurations in .NET Core. And what you want to do is you want to replace the old system.configuration manager with this iConfiguration anywhere you use it. And you want to inject it into your classes instead of having a static reference. But once you have ripped out the configuration manager away from your app, and you've hooked up the provider, you can then start putting things into your apps file from your web config. And this kind of custom provider can look something like this, right? Super simple. You basically inherit from a configuration provider, and you loop over all the config settings in your web config, both the keys as well as the connection strings, and you kind of just add them to this iConfiguration source. And once you do that, you can then create and build a configuration with something like this, where you just add this legacy provider into your build. And of course, here you can tag on your apps.json here as well, which you do normally in your core apps, and then you register that iConfiguration into your DI framework, and then you can inject it into whatever you want to do. So depending on how long it will, depending on how many configuration values you have and how much time it takes for you to also port them in your CI/CD tools, this can take a month or 2 months to do. It took me probably 2 months to get this done, because when you change your web config files over to apps.json, you also want to organize them differently. So you want them most likely in like sections. So you have a nice like JSON section, and in the section you have keys related to the specific section. And that causes your config names to change, because suddenly you have section name : and then the name of the key. So you have to all go into your CI/CD tools to change that as well accordingly, if you want to do that. But you can do it much faster if you like. There are tools there. Andrew Locke has a fantastic tool that he wrote for kind of automatically migrating web config to apps.json. So just kind of look what's out there, and you will be able to use things that works for you. All right, so moving on here. The next thing we want to do here is the dependency updates. And this is a big chunk. Basically what we're doing here, right, is we're going over to all our NNUG packages and saying, you're old, you're really old. You need to get up to speed to something close to the latest so you can run on .NET Standard 2.0. So exactly what I just said here, right? We want to go over all our packages, and we want to make sure that they target .NET Standard 2.0. So if I take something like, AutoMapper, right? Very common, fantastic library. We were down on AutoMapper 3.1, I think, or 3.0 as our version, which is, far away from 10.1.1, which I think one of the latest ones right now. So that version had no support for .NET Standard 2.0 or .NET Core. It was only .NET Framework. And the way you see that is just you look at the NuGet dependency in either NuGet.org or in Visual Studio, and you can see kind of what the dependencies are for your specific use case here. You want to make sure that your dependency targets .NET Standard 2.0 or below. In this case here, you see AutoMapper 10.1.1. It targets .NET Standard 2.0, and that's great. That's what we want to do. So you want to either take all NuGet packages to the latest version, or the version that is at least targets 2.0 or below, whatever works for you. Because of course, the further up you go in dependency updates, the more kind of incompatibilities you get, so the more headache you get. So it's a trade-off, right? So to do that and get that to work properly, we had, we were in a situation where we could not stop development. We had to continue delivering features, and we also did not want to have duplicate branches or long-running branches. So what we wanted to do, right, was that we wanted to go ahead and update every product dependency underneath the API layer to the latest to run .NET Core 3.1 before we started doing the web app. So we basically want to migrate our products in place. If we were to go ahead and switch over directly to .NET Standard 2.0, a lot of things would have broken directly until we updated those packages. So what we did, and I really recommend this approach, is that what you can do is you can actually do multi-framework targeting. So you can target both .NET Core 3.1 and you can target .NET 4.7.2. And then what you do is you just build .NET 4.7.2 for your production and for your CI/CD pipelines until you get .NET Core 3.1 functioning and working. If if you have a small amount of packages and you can update them real quick, you can of course target .NET Standard 2.0 directly. But there actually is there's reasons why you can't really do that for most use cases, and the reason for that is Entity Framework. So this is kind of an important note to make here as well, is that you do not need to update Entity Framework to EF Core when you do this migration. You can actually run EF6.4 on an application running in .NET Core. And the reason for that is because EF6.4, specifically 6.4, is compiled against both. It's compiled against both .NET Framework 4.7.2 and .NET Core 3.1. It's not compiled for .NET Standard 2.0, but both separately. So basically, you can also include a reference to Entity Framework 6.4, and you're good to go. But that means that you can't target .NET Standard 2.0 for EF. So if you have EF in your application, you can't target .NET Standard 2.0 for any of those project dependencies. Little complicated explanation, but basically multi-framework targeting is going to be your key in many cases here. So I encourage you all to do it if you can. And when you do multi-framework targeting, you get a whole flora of tooling and things unlocked for you that you can really help you massage your way out of a kind of in-place dependency. So you can use things like conditional dependencies to really get you started. For example, we had tons of packages that we had yet to migrate to the latest version. And what we did is say, okay, well, if you compile to 4.7.2, all good. Go ahead and compile it. We know it's going to work. We're going to use it for production. But if you're running and building for .NET Core 3.1, don't include these packages. So we can basically use a conditional dependency saying here that only include a package if you have a certain framework in mind for your compilation. And of course, people will say directly, well, if you don't include a package, you're going to get compilation issues in your code because suddenly you don't have namespace available, and et cetera, et cetera. Yep, you're right. And that's where pre-process directives comes in. These are, some ugly things, I think, personally. Before doing this migration, I was like, oh, let's stay away from this old, ugly stuff as far as possible. But they are fantastic in a migration scenario like this because you can basically switch off a whole package or part of your code depending on which framework you're compiling against. So, for example, we have SignalR in our application, and SignalR prior to .NET Core is its own NUG package. And in .NET Core 3.1 and forward, it's actually part of the .NET Core SDK. And this causes some issues, right? Because we don't have a one-to-one package swap. We actually have to wait until we are completely migrated over to start using it. So what we could do was just toggle off the Signal Core package and toggle off all the hubs and code in the back. And then in parallel, start building out this parallel new .NET Core SignalR kind of pipeline with dashboards and everything else, which worked really fine. And pre-process directives really, really helped us to get to that place. So definitely take a look at this because it's going to help you a lot. I don't think we could have done what we did as smoothly as we did without doing this, without using these. And I would just say that once you are on the core, make sure that you remove this very quickly because they are going to kind of clutter your code and make it ugly very quickly. So use them with care. So there's a couple of gut juice, when we talk about updating our dependencies that I really want to bring your attention to. First of all, there's a lot of packages out there that reach end of life, and they have not been ported to .NET Core. We live in an open source world. We love open source. There's tons of good things with it, and I hope we all contribute to open source as we can. But sometimes maintainers, their life, moves on, and things change, and things may not be ported. So, for example, we had two packages that just did not get ported. And one of them was, I think, AutoMock, very popular kind of mocking framework. There was no version for that in .NET Core. So we had to swap off, for our 20,000 unit tests, we had to swap mocking frameworks. That hurt, right? That's a lot of work for 20,000 tests. But AutoFixture is great, and we were able to kind of get that working instead. We also had like a Razor engine, I think. Razor engine, I think it was called, for like email templates that we used. And that also is at end of life, so we have to use Razor Lite instead. And I'm sure you will run into similar scenarios where something you're using today will not be there in the future. So if you already are thinking about doing this, have a look a bit of what packages are supported in .NET Standard 2.0, and if that's something that is going to be feasible for you or not, or if they migrate over. The second thing I want to talk about is behavioral changes. So they are, obviously when you update a package, there will be breaking API changes. That's just the nature of things, right? And those are okay because you know them, you can lean against the compiler, and they will find them. But a lot of things that when you go from like AutoMapper 3.0 to 10.0, there's a lot of behavioral changes too. Like the versions are so far apart that the way that the package actually works has changed. So you may get very unintended consequences of things changing. And we got that with AutoMapper. AutoMapper started behaving very differently from 3.0 to 10.0. And the way we kind of caught that was our functional automated test. And they found that really quickly in our pipelines. But just be careful with this because it may come back and bite you. So just be aware that can change. And the last one is my favorite, which is assembly redirects. When you start going to .NET Framework 4.7.2 here and updating your packages, you will have a lot of assembly redirects. So basically, one package will have a dependency on another package with a different version than what you're already referencing, and suddenly you have a mismatch of dependencies, and they can only load one version into memory and so forth, and it just gets messy. You will have to fight this, and it's tough, but it's okay. You can definitely get over it, and the way of doing that, of course, is adding redirects into your web config. And you can also try, of course, automatic redirects. We tried it; it did not work for us, but I know it worked for some people. But just wake up every day like smiling and thinking, "Hey, it's gonna be a good day. I'm gonna win this war," because eventually you will. It's just not going to feel like that every day when you're fighting it, because it can be really, really tough to fight the redirects because it's not very obvious sometimes what caused them or what's happening there. So, but once you get over this hurdle, you're very close to getting done here, right? You've done your upgrade of targeting for 4.7.2. You got your configuration schema done. You got your updates to your dependencies. So basically, you're in a state right now where all of your lower level projects, like your database project, your domain project, all those things are running on, or at least compiling normally against .NET Core 3.1 and .NET 4.7.2. But now you have your web app left. You have your web API or something like that, right? That you have yet to convert. And this is really tough. This is where it gets complicated because you can change projects in place for anything that's not a web app. Or web API, and you cannot do that for web API. So when you get to web app, you actually have to create a new project completely, and you need to port things over from your old project to your new project. And basically, the steps to do that is you have to migrate everything in your global ASAX to star.cs class. That defines, everything that has to do with your DI framework and so forth. And you also need to start migrating over controllers and namespaces. So namespaces has changed. Basically, system.web does not exist anymore. So you have to rip that out. And that means also a lot of like attributes and base classes and so forth has changed for you. Return messages and tons of fun stuff. So that's going to be quite a bit of work doing that as well. But I still really encourage you to avoid the long-running branch at all costs because it's not going to be needed. What I would just do is create a separate web app here and then start thinking about strategies to port things over. And there's a couple ways to port things over here to that. One way, of course, is saying, hey, I give up. This is tough. Just give me a beer. I'll sit back and enjoy my life, but I'm not going to do this. And, sometimes it's okay. Some apps here, they can reach end of life instead. And you may not want to actually migrate them over to .NET Core. Like we have a small application and a client that is very, very old. It's in web forms. It's very, very complicated to get the web app over and running. And it's just basically easier to rewrite that app in Blazor, .NET Core from the start. And that's okay. That could be one strategy. Another one, of course, is saying, okay, we're going to do this now, but we're going to do a big bang. We won't actually release anything to production until everything is ported over. We'll stop our feature work. We'll just do this. Depending on your team and your client, yeah, feasible. But most times you can't stop all work, at least teams I've been to. We have to continue kind of delivering still for the business. Another approach, of course, doing side-by-side with redirects. So you may have two web apps in different IS instances or Kestrel, and you may have redirects between pages. And slowly you can migrate over one page or part of your app to the new part. Also fully functional. The one that we did that I really, really want to recommend, at least works really well for us, is something I call incrementally without redirects with a small bang. Very bad name, I know. And if anyone comes up with a better name, please send it my way, because I would love to improve this name. But it worked really, really well for us. And I will kind of talk more about that now, of that strategy and why I think that was such a good way of doing it. So to start thinking about that, let's think about what kind of code we have in the web app, right? What do we have in the web API? I think we have two different types of code there. We have something I call slow changing code, which is basically all the infrastructure and piping. So everything you have in global ASICs today, for example, like your DI framework, setting up AutoMapper, setting up entity framework, setting up whatever you kind of have there, logging and tracing and all those kind of stuff. That is infrastructure, and you rarely change that, right? You put it up, you set it up one time, and maybe occasionally you start adding a new library or thing, but basically it's pretty static. It doesn't change a lot. It's rare that it goes in and does anything there. And then you have everything else, like the fast changing code, things that change by new features and sprints. So controllers, view models, and services that you may have in the API layer still. Those kind of things, right? They can change at a whim depending on what feature you have in a sprint. So you can never guarantee that it's not going to be unchanged. And the reason why you want to separate these two things out is because if you start porting over things into a new project, if you start porting things over that change a lot to your product, that means you have to make sure you also keep that up to date. So any change in the old product for production code right now needs to also be ported over to the new product. And that can be very difficult to keep kind of balanced and synced up. So that's why you need to make sure you make a distinction between those two, because each type of code here needs a different approach on how you port it to your new web app. So again, I mentioned that you have slow changing code for Autofac, AutoMapper, like all the piping. And the way we did and handled this part of the code here is actually we had sprint features tickets in our sprints. So we basically said, okay, now we're going to go ahead and wire up Autofac for .NET Core. So we're going to create a ticket for it. We will define and flush out the technical analysis and requirements for this. And we are then going to do one of those things per sprint. So some developers will jump on Autofac in .NET Core, and they will wire it up in the new web app, and they will test to make sure that Autofac works in the new web app. And then we continue doing that for every kind of single thing here. We can do AutoMapper and authentication and all those kind of things bit by bit, ticket by ticket, and without doing anything that's breaking. And this is a great way of doing it, because you get the team really involved in some of these things that they may never get exposed to otherwise. And you do it risk-free, because you're doing it to a new web app that doesn't go to production, but you do it in the same code base in master. And once you kind of have this solid platform that you can stand on, so you can at least open your application on like one page, whatever that is, then you at least you have your platform there. You can authenticate yourself, you can wire up your DI framework, you can do kind of those stuff, very basic stuff, but the platform that you kind of rest on. If you then move over to the fast changing code, right, the controllers and the view models and so forth, that is very different and needs to be treated differently. And the way we did this, we actually used a custom tool for this. So we created a custom console application to handle these scenarios. And I'm going to walk you through our thought process here, because it's a little bit complicated, but I hope you will kind of appreciate it once we get to the end here. But basically here to the left here, we had our master branch in .NET Framework, right? And what we did is we created a console app, very small console app, that could run against our branch, and using regex and other things, convert our web app to .NET Core. Basically saying it will take everything from an old product and it will move it over to a new product. And it would, while doing it, it would convert things that are common. Because when you start looking at the fast changing code, the common things that you have to do are things like namespaces, inherit from other base classes, change attributes, maybe do some other redirect somewhere. But they're pretty you can standardize them quite a bit. So for example, we did global namespace adjustments. We moved over files physically. We renamed projects. We removed the old projects. We started targeting .NET Core for every product that we had instead of having multi-framework targeting and so forth. And it's perfect because you can run this tool for 5 minutes and suddenly you have you have a fully functional web app in .NET Core, and then you can start experimenting on that. You can start, okay, let's do it manually. Let's open it up. Does it work? Does it break? we can start like throwing all of our automated tests on it, our UI test and API test, and saying, does it actually respond? Does it work? And a lot of times you'll find that no, it does not work. Things are breaking. Oh, we didn't expect this, or we didn't see this one coming. And that's great. The whole idea here is you do it incrementally. So you discard that branch, and then you take the learning from your experience here and say, okay, is this something that is very specific to .NET Core that I can't do for applications as a whole? If so, add it to the tool. Say, okay, I'll update the tool to also adjust this little thing for me. If it's something that is more global that you can actually do to the master branch directly, because it applies to both the .NET Framework version as well as .NET Core, or you can just do it straight into the project, then open a ticket, create a ticket, and prioritize that in future sprint and adjust your work based on that. And then you continue doing this kind of experiment. You run the tool and you try and see how it works, and you can slowly learn what you need to fix in your web app until you get to a place where everything works. And the cool thing with this is that you get so much confidence in your application without committing to anything. You don't have to commit any code to master branch. You don't have to deploy anything to production. You just have to kind of experiment. But you do it in one branch. And I call it deferred branch approach, really. But once you get to this place here, you actually get to a place where everything works. Suddenly you have web app in .NET Core. All of your lower level things are converted as well using the tool. And all of your automated tests are working. And suddenly you can take this branch here, and using a PR build, you can deploy it to non-prod environments of your choosing and have users or QA manually test it as well to making sure it actually fully works. And when you feel like, hey, we're on the right track, this works great, everything seems to be working, then you can commit to actually merging this to master and really committing to this migration and saying, okay, we're good to go. We feel very confident here. We can go to production. So it's a nice way of getting some real security and safety around this as well. And I'm happy to chat more about this approach, offline or during questions, because I know it's a lot of things in this diagram here. But this is if there's something to take away from this talk today, I would say this is one of the most important pieces, because this is very custom for us and it worked really well. So the only thing I would say as well, when looking at the web app and migrating things over to .NET Core, there are a couple of things to think about that may not be obvious. So for us, for example, we had a lot of ambiguous endpoints, basically endpoints in the same route. And that's really bad, okay? But it works in .NET Framework because you have an order attribute and it still kind of finds the right way. .NET Core is much more strict. It does not approve of that, which is great. But basically, you have to be aware of that if you have that, because your web app may not start. The second thing I want to say as well is that from our UI in Angular, sometimes we didn't actually provide the full payload to our API. So we may skip a Boolean value because it's false, but so we like, okay, well it's going to be false, so we don't actually provide it in the payload, and the API then sets it to false in the back there. We're all good. .NET Core does not do the same thing. If you don't set the correct, the full payload, it's not going to by default just set the default value. It's going to actually throw an exception. There's ways around this. You can create custom converters to do this for you, but it's also something to think about. And I think this goes into performance overall .NET Core. This kind of clean away some of these edge cases, so the majority doesn't need them anyway. But there are ways around it. It's just that you have to think about them when you develop this. The third thing I want to mention as well is the API controller attribute. So you can decorate all your controllers with the API controller attribute or your base controller, which kind of gives you the ability to bind post payloads to your methods, and does a lot of other fun stuff that you really need. So in general, I think it's a good thing to do it, but just be careful with it because it does some things that you don't want to sometimes. For example, we had custom validations on everything we did. So if something comes down to the API, we want to go over the payload, and then we want to generate a custom message, very custom, and return to UI. If you have the API control attribute, it actually won't do that because it will bounce back and say the payload is invalid before we even get to custom attributes. There's also ways of suppressing that behavior, but again, just be aware that it's the case, so you have to do that specifically. Other things we run into as well, are if you work with BizTalk, for example, we started having issues with BizTalk being able to authenticate to our API. So suddenly, a BizTalk couldn't actually pass all the credentials to our API through a Kerberos ticket, and we had issues with that. And the way to solve that is actually enabling impersonation in BizTalk. So if you ever use BizTalk to hit your API and you have issues with authentication, make sure that BizTalk enables impersonation on their front, and you will solve that by itself here. So we have ported the web app. We have done all the hard work. We are almost at the finish line right now. And the final piece I want to touch here, real brief, is just to talk about our CI/CD pipelines. And it's really just one slide, but it's something that I think is very important to mention. So, when you are on .NET Framework, you will be relying heavily on MS Build, right? MS Build is going to be your friend. When you move forward to .NET Core, you don't need MS Build anymore, which is great. We all don't like MS Build, I think. So you can rely on the .NET CLI instead to do your build, test, and publish, and everything in between. And you're going to find that your build scripts and your CI tooling is going to be much more precise and much more condensed because of this, because you need to define a lot less. So it's not a lot of work, but just be aware you need to plan for this as well. You need to plan for updating your pipelines to use .NET CLI. And the way we did this ourselves was that we actually duplicated our pipelines. We used TeamCity. But you can do this, of course, in Azure DevOps or GitHub Actions as well. But basically duplicate your pipelines and let them run in parallel. And then when you feel like your CI/CD tool builds your .NET Core version of your app properly, you can then just start using that one instead of the existing one, and then suddenly you're out of the problem. And the final thing I want to mention as well is that I mentioned before that we did not go to EF Core directly. We went to EF 6.4 instead, and we stayed on that. And I really encourage you to all to do it if you can, because if you have a large footprint of your application, like we had, like 500 entities, changing to EF Core, or EF5, I guess it's called right now, it's very risky. I mean, it's basically porting you to a completely new framework. And you may run into a lot of data issues by doing that. A lot of stuff that are different. And it's all good. You should do it at some point. But you may want to hold off on that migration until you're fully on .NET Framework or .NET Core first. And then start a separate initiative, because it's very risky. But if you stay on .NET Core and EF 6.4, just be aware that running migrations and adding migrations is a little tricky. You can't use the migrate.exe anymore. You have to use ef6.dll. And there's very little documentation on how you actually run and create migrations in this kind of intermediate land here. But fully doable. You have to create basically some PowerShell scripts to do this, because there's a lot of specific coding to do that. But if you have questions on this, or if you want help with this, reach out to me. And I'm happy to provide kind of the ones I have that we used. But I spent quite a bit of time for me, actually, to figure out how to do this myself, because it wasn't very obvious, and Microsoft does not want people to be in this limbo land for too long. So they don't have any documentation at all actually on this. There's just a small thread, I think, on a GitHub open issue that you can look at that gives you a hint on how to do this. But it is doable, fully doable. So please go for it if you can. Final slide here before questions is lessons learned. I would say that functional test is going to be your friend. Add them if you can, because they're going to really help everything. But don't care too much about unit tests, because they won't really tell you if your upgrade is working or not. As I mentioned, pre-processor directives is really, really helpful. Embrace them if you can. If you want to change your products in place, definitely look at them, because they'll be helpful. There's no need to migrate to EF Core, as I mentioned. And also consider staying on IIS. A lot of folks want to go straight to Kestrel, right? Because Kestrel is cool, and that's why we have .NET Core. But you can actually run .NET Core in IIS as well. And again, I would think about what are the things that you can do to get to .NET Core first before taking on new technology like that. Because that can be helpful to limit the scope of your risk and limit the scope of your work and get more value to your client and your business before anything else. Also, I would say that migrating the web app is the hardest part. That is going to be the most complex part. The rest is tedious and tough, but it's not so complicated as opposed to just have to do it. But the web app is very complicated, but fully doable. And I encourage you all to go down that route, because it's really fun to be on the core. It's fantastic for application. It's, for us, we had like a 35% performance increase. It's just something that you want to do, and it really makes sense. So hopefully what I've showed you today has been helpful for you down that route, and giving you some thoughts on how you want to do that as well. And hopefully I have given you some confidence as well that this is actually possible and not just a pipe dream that it's not going to happen. But I'm going to leave the floor open and give it back to Håkan and Henrik now for any questions that you may have. But I just want to thank you for joining this session today. And you can always find me on Twitter, on alex.dot on Twitter, or on GitHub if you have any questions or any thoughts after this talk today.
All right. So thank you, Alexander. Quite a knowledgeable and very concrete examples and helpful hints you had. So definitely a talk I will forward to my team. It was really nice for us stuck on the .NET framework side for a bit longer. Not too many questions from the audience, but I have one for myself. If you had to do it all again, what would you do differently?
Good question. I think what have I done differently? I think I would have involved even more team members in it. We rotated in and out team members, but only specific people, because those were the ones showing interest and want to be part of this transformation. We should have kind of more or less forced some more people kind of involved, because once you are on .NET Core, there's a new way of doing it. There's also other things to think about, and it's also really engaging for the team to be part of the transformation and own the application. So this is a great way of you kind of upskilling your developers, if you will, and making them part of the solution. So doing that, I think, would be something that I would have done differently. I would also, if I would have known this before, I would have spent less time trying to migrate EF Entity Framework to EF Core. We started trying to do that for like a month, and then we just realized, hey, you don't need to do this anymore, and we dumped that. But that was also like a wasted month. So I wish someone had told me before that was not needed for sure.
Okay, thank you. And we have one from Oddbjörn. So I'll read it out loud as well. Any thoughts about the different Microsoft support policies of .NET Core and full framework?
Yeah, absolutely. I mean, so as you may notice, Microsoft is going more towards like instead of doing like 10-year support policies, they're doing short support policies. Because they're in their thought and their mind, software and applications needs to move with time, and they can't remain static and forgotten in a closet somewhere, but it needs to actually be maintained and continuously improved. With that said, though, .NET Core 3.1 has long-term support, and I can't remember what the actual number of years is right now, but I think it's like 3-4 years, something like that. But also .NET, I think 6 will have the same. I don't think .NET 5 has that right now, but they will do a yearly release every year, and I think every 2 or 3 years they do a long-term support version that will give support. So I wouldn't expect there to be any kind of issues rather than that. I would actually say that it's easier, because good thing with .NET Core, right, is that it's open source, and it's much more engaging on GitHub. So you have a lot more GitHub issue threads that you can follow down, instead of like older Microsoft support forums that doesn't always make any sense. So for me, at least, I think it's much easier to find solutions for things I struggle with in .NET Core than in .NET Framework.
All right, and thanks for the question. So we don't have any more, so I think I'll take the opportunity to say thank you to Alexander, and we'll take a short break now in the stream, and we'll be back with Johan on the hour at 6 p.m. So
thank you very much.
Thanks, Alexander, and see you guys soon.
Bye-bye.
Bye-bye. Okay, welcome back everyone, and I hope you're enjoying today's Global Azure Norway. And for any newcomers to the stream, my name is Henrik, and I'm part of the Norwegian.net user group who are organizing this event. And I'll be your host for this session. If you have any questions during the talk, please use the chat to post your questions, and I'll include them in the Q&A session after the talk. Here is your second speaker for today, Johan Ludvig Brattås. Thank you for joining us, Johan, and the screen is yours.
Thank you. All right, you should be able to see my screen, and let's start. So today's topic is how to create a modern data platform in Azure. My name is Johan Ludvig. I'm a lead solution architect at Capgemini. You can find me on Twitter or on these other contact info. I also volunteer a bit like some others do. And when I'm not geeking out, I teach celiacs how to bake gluten-free food. So, topic for today, modern data platform. How should we build it? But first, to understand the background of this, I'm going to talk a little bit about data warehouses and data lakes. So for those of you who think this is basic, I apologize, but hopefully we come to the good stuff pretty soon. So the data warehouse has been around since 1988 in one form or another. It has evolved over time, and we are now normally doing data warehousing using three main approaches. You have the dimensional approach, or Kimball. You have the normalized approach, aka Inman. And then you have Data Vault, which is now running on version 2.0, which is more of a cloud-ready approach than the other ones, or the previous version. So the data warehouse itself is subject-oriented. So it looks at data across the estate instead of a transactional system that looks just at transactions coming in. It is integrated, so it tries to merge all the data systems from the various sources behind and lift them up to a point where it's easier for people across the industry or the business to understand what the data is. It's time variant, so it looks at changes over time and looks at data in a time perspective and not just a right now picture. It is non-volatile, so we prefer not to delete anything. We rather insert and update, change to the new versions, and then you can have a historic view of changes of a certain subjective. And of course, it is summarized, so it's dealing with sums and aggregations, and it contains structured data, so schema on write, and it's relational data, so it's an RDBS system, and it stores historical data. And because it is an integrated subject-oriented system, all the data needs to be transformed to adapt to the data warehousing needs. And this is why also, before you present it and store it for presentation for users, you transform it before you land it in that stage. And a data warehouse is very good for business decisions and for understanding why or what happened. But because it's business decisions, it needs to have a focus on high quality of the data and to be exact on the numbers. So you need to know that when you're looking at the sales figure, it is actually 300,000 NOK and not roughly that amount. This leads to long development life cycles. Data warehousing has a reputation of being costly and lengthy projects, and business users forgetting what they actually asked for when they finally get what they ordered. This, in combination with increasing data volumes, meant that relational databases started struggling with performance. And a data lake gained foothold in or around 2011 to answer some of these pains that the data warehouses were struggling with, whether you're saying 3 Vs or 5 Vs or 4 Vs of big data, but at least let's look at volume, variety, and velocity of data. Data warehouses struggle to keep up. So the data lake comes in mainly 2 different versions. You have the raw data lake, and you have the business data lake, or if you want, a layered data lake. And the business data lake builds on top of a raw lake, so it lands all the information that you can as is with no modification. Again, raw data. It then encourages line of business to create point solutions. So if sales wants a sales dashboard, they can create their own solutions down in the data lake and pull the data and transform the data that they need. This lets the line of business decide on the cost performance for their problem, which means that IT can concentrate governance on critical points only, making sure that the data is available, that there is enough space available, and so forth. And in the business data lake, the corporate view or the enterprise data warehouse-ish view is just another line of business on top of the data lake. And all information is valid, so whether it's structured or unstructured, it's still information. However, you shouldn't assume that the data lake contains everything, even though we try to land as much as possible. And scale is driven by demand, so you should be able to both scale up and down according to the needs and demands of your users. And again, yes, data lakes in its basic form is just a repository of raw data, such as blobs or files. It's schema on read. You don't really need to think about the metadata of the files and the formats that you're landing in. That's something that you take care of whenever you need to read that data. And it can contain both the blobs, but also a relational database. Both raw, relational and unstructured, or structured and unstructured data is valid forms in the data lake. And of course, you store as much data as possible, and you don't transform anything in the raw layer. That will happen at the later layers in the data lake. And data lakes typically have various use cases and users on the various layers of the data lake. So data engineers and data scientists and advanced analysts might go down into the raw layer, whereas a regular business user normally doesn't see anything beyond the upper layer or the most curated data for their specific use case. Data lakes in themselves adapt very much to trends and ad hoc analysis. And because you don't have any data quality controls in place and you don't need to think about returning exact answers, you have a lot shorter time to market development cycles. And it is a great enabler for data science and self-service analysis. However, because you can land as much data as you want, you do end up in the danger of a data swamp where you have so much data that nobody really knows how to find what they need because it's unwieldy, and if you don't know what you have, it's impossible for the users to actually start using that data. So a data platform is an approach where you have the enterprise data warehouse, which is well established. So why should you, after have spent X amount of million Norwegian kroners or dollars on this, why should you throw away that development? And it works very well for its intended purpose, so business cases and looking at summaries of things. Data lake in itself cannot really fill the shoes of an enterprise data warehouse without taking on parts of the form and function of one. Bill Inman had a post on LinkedIn a couple of months ago where he claimed that data lakes is just another way of showing data warehouses, because in his view, everyone that creates a data lake needs to transform that data into a data warehouse kind of solution, which isn't true because they both have different functions to fill. But a data lake has a raw layer, so which is typically the same as data warehousing terms is called a staging area or an operational data store. So why not just use the raw layer of a data lake as the staging area for the data warehouse? These can be joined. So a data platform is an approach where you say that you take on the warehouse functionalities, and with that also the development cycles and quality controls and so on, as well as offering the data lake benefits of ad hoc analysis, self-service, data science, but there is also more. So typically in the data platform, you have your sources, whether that is a stream of data coming in or that is batch loads, doesn't really matter. You have a data orchestration tool of some sort to pull data from the sources, make sure that they go on schedule or on a trigger, land that data in the raw layer of the data lake. Then you have one or several functions to transform that data in an ETL/ELT approach. You might want to use a traditional ETL tool, or you might want to do massive parallel processing on big data in chunks. So you can use things like a Databricks cluster to do that. Then you land that data in the serving layer. That can be curated data lake layer, and it can be data marts in your SQL data warehouse, or it can be a combination. That depends. Then you enable analytics in the form of machine learning services, or you have your data marts aggregated up in analysis services or in Power BI. And then you have the end user tools to present data in, whether that be Power BI desktop, where people can then connect to the data lake or data marts and do self-service analysis, or if they just consume dashboards and reports that are pre-made for them in Power BI service. And typically, again, the different users have different needs. So data scientists and data engineers typically play around in the raw layer and upwards towards the serving layer, whereas business users and regular analysts tend to come in from the self-service or consume layer of this platform. So data platform delivers both regular analytics as well as big data analytics on top of your data lake. It is a great empower of self-service BI, again, because you can let your users gain access to the data in the shapes that they need for their analysis, as well as bring their own data into the mix. And it enables data science and ad hoc analytics, while still the data platform still needs proper services for performant data warehousing on large data sets. Again, that kind of quality and exact figures won't go away as long as you have that kind of business need. And of course, you still have the same challenges as you do in the data lake. If you just load data in without mapping it and knowing what you have, you will have a data swamp. Because again, how can users find and make use of that data? And how can they know the data quality and what data is used for trending and what is actually an exact truth from a business or enterprise perspective? So now to the main part, platform options on Azure. There are actually several different opinions or options available to you to run a modern data platform on Azure. The first one we'll look at is the data lakehouse. I'm a bit in two minds when it comes to that terminology, but it has caught attention. There are a lot of people who like it's quite catchy. But data lakehouse was coined by Databricks. It follows the same kind of pattern I've described now with the data warehouse, with the data lake, and then onwards to a platform that allows both streams to be analyzed on, enables data science, but still serves traditional BI and more advanced analytics on top of any kind of data. And the typical features described of a data lakehouse, it has transaction support, so it needs to get data coming in regularly, whether in batch or streams. It has schema enforcement and governance, so you make sure that the data is being landed in a proper format and being defined, so it's not a schema on reads, but a schema on write enforcement. But you also need to make sure that you have control of the schema and schema variations over time. It has BI support, again, traditional BI reporting needs. Storage is decoupled from compute, so you can store as much as you want and you only pay for what you process. It contains open formats, so it has to support both things like SQL, which is in itself an open format, but also support Parquet or other open source formats instead of proprietary formats. And it has to have support for diverse data types. And it needs to support diverse workloads, whether that be stream, batch, micro, near-time analytics, as well as real-time, and then down to micro batch and once a day batch. And it needs to have, again, data streams, but it has to have end-to-end, so from all the way from ingesting that data all the way through to the dashboards with live data. And if you don't have support for the end-to-end streaming, it's not part of what the definition of a data lakehouse is. At the heart of the data lakehouse platform is the Delta Lake. And Delta Lake is an approach, it's an open source format that takes Parquet files and adds transactional integrity to them. And then you have different tables. So a set of Parquet files is defined as a table. And you can have ingestion tables as bronze, you have refined tables as silver, and then you have the data stores, aggregations, feature-defined tables as gold. And all of that runs on top of your existing data lake, whether that be in Hadoop or S3, or as we're looking at here, in your data lake store in Azure. So Delta Lake is open source, which is very important. Again, back to the lakehouse approach, it has to be open. It is based on Parquet, but one table is a set of Parquet files. So it's not just, or it might of course be just one, depending on how small it is, but it is based on Parquet. But what it adds in addition is transaction logs. So for all data being streamed into the Parquets or into the Delta tables are also logged in your transaction log part. And that brings the ACID principles to the data lake. So you make sure that you have high integrity and transactional integrity on the data that is being stored in the data lake. Transaction logs also supports time travel, because then that means that you can take one transaction or one object and track it through the logs back in time and see what has changed over that time period that you're looking at. So you have windowing. Delta Lake is also able to handle both batch and streaming data sources, as well as being the source of streams that pick up data from that Delta Lake. And it has schema enforcement, so it makes sure that the data is being stored in the proper defined schema. But it also supports schema evolution. So if you want to add a column, or if you want to change the data type of a column, it will be enforced throughout the different Parquet files that are underneath that Delta table. And it also supports updates and deletes, which isn't your typical way of approaching a Parquet file. And because of your transaction log, you also have an audit history. That means that you can go in and see when something has been updated or deleted, and probably, it can also handle logging on who did or what system did that insert or delete. So in your data platform, again, you have your different sources. You have your ingestion, be that handled by Data Factory. You can also use Databricks for a lot of this in itself. Transformation being handled by Databricks. Serving is handled within the Delta Lake on top of Spark tables, Spark compute nodes that answer when you are querying against the Delta Lake. You run your analytics in Databricks, but you can also do ad hoc analytics in Power BI against Delta Lake format, or you can query the Delta Lake through Spark or Databricks in this case. But why is the data lake house mentioned in this aspect? I know that Databricks is a separate company, even though it's run as a first line service in Azure. But Databricks has also defined Synapse as the only other solution right now that is data lakehouse compatible. So Azure Synapse, the full stack of Azure Synapse, is defined as a data lakehouse compatible system, which means that you don't need to restrict yourself to a Databricks solution if you want to build your data lakehouse for future use. And then again, it's just a matter of changing out Databricks with Azure Spark, but you can also use either, or right now you can only use Delta Lakes with Azure Spark. Hopefully they will introduce support for SQL pools later on. I know there is a user voice question about that, because then you can use dedicated SQL pools for data warehousing needs, or you can use serverless SQL pools for ad hoc analysis and build your solution across both Spark and SQL. Databricks also has a SQL Analytics solution that was released in November last year. I haven't been able to try it yet, but that should offer some of the same kind of functionality from what I hear. Of course, in the analytics space, you can use Azure Machine Learning Services, or you can use Azure Spark for doing your machine learning, and Power BI on top of this, either through Delta Lake or through Spark or through SQL pools, depending on how you put that data in. Second pattern is more of what I call a modern data warehouse. And in this format, we're looking at Synapse. Going back to what I mentioned earlier about data ingesting in Azure Data Factory, then you have the big data transformation in Spark or Databricks. You store your data in the data lake store, and then you had SQL Data Warehouse as the main data warehousing or serving layer in Azure. Synapse tries to build on top of that, and then of course Azure Machine Learning Services and Power BI being tightly integrated into this as well. One point that both Databricks and Synapse has is that it also has a unified workspace or analytics workbench where your data engineers or your analysts or your data scientists can sit in a common developer experience, common data experience, developer platform, and run your Python, your Scala, your SQL, your R development. But also in Synapse, you can run .NET Spark, which is a new adaptation of what was previously called USQL, to be able to run Spark jobs without having to know or learn a new language such as Python, which is typically what people will be using in Databricks. Both Databricks and Synapse, of course, supports traditional SQL, either through Spark SQL or through T-SQL. And in the pattern I showed you, again, we are talking about having an ingestion part. However, in Synapse, you have your data factory integrated as well. So you have Synapse pipelines taking over the role of Azure Data Factory. Then you have either transformation through ELT using SQL data warehouse, or now called dedicated SQL pools. You can have your big data processing using Spark, for instance, and then you do serving of that data on dedicated SQL pools in your traditional data warehousing format, but also using Polybase, which is a technology that lets SQL pools connect to the data lake and pull data in through CSV, Parquet, JSON, XML, and present it in the SQL interface as an external table and being queryable in regular SQL. It can also connect to other database systems such as Oracle or Teradata on-prem, though I wouldn't really recommend doing that approach. It's, unless you have a very, very, very fat bandwidth. And of course, you do Azure Machine Learning Services, Azure Spark on top of your SQL data warehouse. And what you also can do in SQL data warehouse or dedicated SQL pools is you can take your machine learning models, as long as they're in the right format, import them into SQL pool, and then being able to do query those and trigger those models within SQL. So for instance, using a predict statement in SQL, you can run and query against machine learning models residing within your database. And of course, you connect Power BI on the end for end user consumption and ad hoc analysis. It is possible right now to build reports from your Synapse Studio. However, you will still need to first open up Power BI desktop and connect to Synapse or your data lake to create the data set that the report will build on, and then publish that before you can actually get to use it in Synapse. Hopefully they will do something about that, so it gets easier by over time. A third pattern on Synapse or in Azure is the logical data warehouse. And a logical data warehouse, again, using the same tools as in that you have in Synapse, lets you build a virtual abstraction layer on top of your data lake or on other data sources in Azure, which lets you have a virtual front either of your SQL data warehouse or dedicated SQL pools, or you can use your serverless SQL pools and build external tables on top of your data lake. So external tables, again, supports things like Parquet, JSON, XML, CSV, and you call them as external tables or open row set in SQL. And then you can build views in your serverless pools that can then on demand query and return that data for you. Or you can build materialized views or import the data into your SQL data warehouse, depending on your needs, and have it running on a more dedicated cluster of compute. The serverless SQL pools are pretty new. I know there are people who have some issues with them. They're not perfect yet, but they've gone through a lot of nice changes, and it looks really promising. So it's worth checking out. And again, the combination of using serverless SQL and dedicated SQL means that you can build a proper logical data warehouse without having to do a lot of transformation on top of your raw layer, and let your users access that in a very quick and easy fashion. And it is pretty much a deliverance on logical data warehouse. I can't remember when Gartner coined that, but I think it was back in 2010 or something. So it's an old concept, but I haven't seen a really perfect I haven't seen a really perfect adaptation of it yet. But the way that Synapse is approaching this and Microsoft is approaching this means that you are a lot closer to having something easy to set up without having to spend too much time on learning new technologies and new systems, or even purchasing more expensive licenses. So these are the three different patterns for your data warehouse or your data platform on Azure. But to have a proper data platform and have the keys to success, there are different aspects as well that you need to think about. And one of them is, of course, when you're building a platform or a house, you need a foundation. And that foundation consists of different services, such as encryption. And the different options available for you in Azure is, of course, and the default is data encrypted at rest. And all data in the data lake is encrypted at rest, as well as your SQL databases are also encrypted at rest. Though as soon as you load data into memory, that data is then unencrypted in memory. You can, of course, also bring your own key so that you take full control. That also means that Microsoft loses the ability to help you in case you need to, you run into any problems, lose your key. But it is, of course, the safer option to protect your data. You can encrypt data at the application level, which means that even when you're loading it into memory, it will stay encrypted until the application decrypts it. In Azure, the only way of doing that right now is always encrypted in SQL Server. And always encrypted means that you can define a table or a set of columns, or even one single column within a table that has to be encrypted and stored encrypted. You have two different ways of encrypting. You have regular encryption, and then you have, and now my mind's frozen, but a patterned encryption, which means that even though it isn't not a safe encryption, it is possible to run query tuning and indexing on top of an encrypted column. So this means that you can store the data encrypted in the tables without having your DBAs or consultants or untrusted employees reading the data that is encrypted. And it is only then decrypted when it arrives at the front end. For instance, if you're storing HR data and you only want the end users to see, you can use always encrypted. SQL Server now also, or sorry, Azure SQL comes with something called always encrypted safe enclaves, which means that within the database, within the memory, the data can be encrypted inside the SQL Server. For instance, if you're doing aggregated queries against an encrypted table, that data can be safely decrypted in an enclave, aggregated and returned an aggregated response to the user. And this is still in preview, but it's already set in production at some companies. I read a blog today, I think it was the Canadian bank that had started using this functionality. And it's part of the trusted computing initiative that Microsoft has with Intel and AMD chips at the hardware level to make trustworthy data trustworthy data services for users. Second, of course, is you have identity access management. Might be that you say that this is the main and first topic to look at. But again, in identity access management, to enable authentication and authorization of users through role-based access and so forth. And that is, of course, Azure Active Directory. And that is also important when you are storing your data to make sure that data is only accessed by people who are authorized and authenticated to do so. You want to have a set of security features in place as well. Network security groups. Azure comes with a security center where you can monitor your services. You need, of course, to think about when you're moving into the cloud that you don't have a perimeter security anymore. You need to look at a layered security approach instead, because in a public cloud, you don't really own that boundary or that perimeter yourself. Azure also has a nice advanced security feature called the Azure Sentinel, which applies more advanced analytics on your logs and your services and monitor them in real time, and then can predict or recognize patterns that are deviating from normal. You, of course, also want operations in place to make sure that you have alerts when services go down or your pipelines failed, and that is run through Azure Monitor. And you, of course, also want to have source control in place. And since we're in the cloud, you want to have your infrastructure as code into your code repository as well, and try to build a CI/CD pipeline, which is either through Azure DevOps or, in this case, GitHub and GitHub Actions. However, that was the foundation. But to make sure that you get a success with your data platform, on top of that solid foundation and on top of the fancy data layer that you have, your users need to have trust in your data. They need to know that the data is there. They need to know what kind of data is there. And that is something that you store in your data catalog or your metadata catalog. And your data catalog in Azure was previously known as Azure Data Catalog version 1. And after a long wait, because that was a very, very simple and quite chunky service, in November, or was it December, Microsoft launched Azure Purview as their new data catalog service built on Apache Atlas, the open source format. Azure Purview also contains a business glossary. Again, if you want to make sure that you have the right definitions of, on the boats, for instance, of what a passenger mix is, whether that be how many people from different countries have been sold, so how many people from Sweden, Denmark, and Norway are on board, and where have they purchased from, or if it is passenger mix as defined in how many lorry drivers, how many pensioners, how many families with children are on boards to define on or to plan on if they're going to hit the bar or the tax-free or just stay in their cabin eating food they purchased at home. So these kind of definitions need to be put into your business glossary. Purview is the main one. It's pretty cheap, but it's still in preview. For other metadata management, you can also look at things like Elation, which is a fully featured third-party catalog, but it is a bit more expensive, but has also a lot more features. Or you could go for something like the Rolls-Royce of data catalogs, which is Informatica Enterprise Data Catalog, which is the market leader, but of course the price tag is also quite hefty. There are also a lot of other different options, such as Calibra, SmartLogic, blah blah, and there are open source options such as Amundsen and several others. Also, to enable trust in your data, you need to think about data quality. So how many duplicates, how many rows with bad format on it, and so forth. And data quality in the data warehousing kind of approach normally tends to be make sure that we don't get duplicates, make sure that we don't get any rows where we have the name of a person in an address field and vice versa, or a phone number in address field and vice versa. But in a trust environment, a data quality tool is also a tool that can connect to and scan data sources and look for patterns, so you can predict and help your data quality controls at a much higher level and more advanced level than just making sure that your pipelines don't fail. Azure Purview is not right now part of a data quality setup, or they don't have a tool for that. But from what I hear, they might be coming within the year or two. So I just put that in here for now. Otherwise, you need to look at the more advanced and third-party tools for data quality. Data lineage is also part of Purview. And right now, I think that Purview is the only data catalog that can actually scan and map out the lineage of Data Factory, though that will change over time. And just to show you how that can look in Purview, I have opened a Purview Studio here. And Purview has different sources mapped out. This isn't very fancy. This is just a test for this. But you can set it up to scan your entire platform. So it scans the data lake, maps out all the different tables that are there. And then you can, sorry, that was the wrong one. You can see on... now, where was I? Yeah. Let's see if it comes. Go on. There it goes. Yeah. So it maps out different information on the assets that are scanned, what kind of source types I have in my data lake, how many assets or files are in the data lake, and it can classify the assets as well. And on top of that, I can browse different assets. So in this case, I have Data Factory, I have Data Lake Store and Blob Store and the SQL Server. And to go through the lineage, you can go into your Data Factory. And then you can take a look into one of the pipelines that are running here. And it will, apart from showing you the assets and what it has read from that in metadata, it also has the lineage showing you the source, what the Data Factory copy activity is. You can even open that asset into Data Factory. And then it shows which outputs it has on the different ones. And then again, you can go into and map that as well. So it's still pretty basic, but it has some nice features. And this is, again, something that is important in the data trust part, specifically when you're looking at either from a KPI perspective or a dashboarding perspective, or you need to know from a compliance perspective what has been done to the data that we're looking at to end up being reported as it is, whether that be definitions or business rules being applied through transformation to define what is a loan against secured assets or an unsecured loan or similar. So lineage is also a very important part for users to have that data trust component in. The last part of data trust is data lifecycle management. And data lifecycle management is to make sure that the data that you have in your data lake is there that it is being used properly, and that you don't store data that has no value to you, because as long as data is just being stored, it's just another cost center. You don't get value out of your data until you start using it. And storing data in the data lake or in the database costs money, even though it's quite low. When the data volume increases, of course, the cost comes at the same thing. So a petabyte of data in Azure will be something like 100,000 kroner, so $10,000 or something per month in the hot tier. But storage account or data lake storage account has different tiers. So you have hot, cold, and archive, where the hot has a very considerably higher storage cost, but the read and write cost on that data object is quite low. Whereas in cold and archive, you pay a lot less for the storage, but the read and write on that data object costs considerably more. And when you deal with archive mode as well, that is basically tape storage. So you also have quite a high lag to pull that data out and serve it afterwards. But being able to move data between the tiers on the policy is something that you can do in Azure. I'm not sure if they've opened up yet. I know that they mentioned that earlier, that they should be able to scan data on last access date. But you can also scan data on last update date using things like a logic app that triggers every month or something, and then move data in between storage accounts that are in different tiers, so that you make sure that you don't pay more than you need to. And you can even then have Power BI dashboard that tells you which files have been dormant and not accessed last 10 years or 5 years or something, as a warning that an administrator needs to go in and consider deleting that file because it's just taking up space and costs money. So that's the data lifecycle management part of the data trust. And as long as your users don't know where that data is, they don't know if they can trust the data, they don't know exactly what that data means, it doesn't matter how much fancy hardware you're using or how fancy your data models are, you don't get people your users to actually start using that data in a proper way. So this is why trust in data is the most critical success factor in any self-service and any modern data platform that is being built. And with that, I'm on time, and I wonder, are there any questions left? Or any questions at all? You're on mute, Henrik.
Sorry for that. I'll repeat. Thank you for a great talk, Johan. And we do have a question. So the first one is from Mitesh, and I'll repeat it now. When people say that they have source databases and are trying to get the data in a data lake, does it mean that they are transforming the data and loading it in a file-based repository, meaning data lake?
Yes and no. If they have a source database and trying to get that data into the data lake, they will then, yes, pull that data out, extract it, and land it as files in a data lake. They can, of course, define a database as a target in a data lake, and it will still be valid. Again, going back to what I said about data lakes storing both relational and or unstructured and structured data. But typically, you land that data as a CSV file or Parquet file without doing any proper transformations on it in the data lake.
Well, thank you. And a follow-up on that from Mitesh as well. What is the advantage of doing this if we are going to convert the data from a relational format to a file format and to load the data, load in data lake and then convert it back into relational format to load in a warehouse?
Well, first of all, storage on Azure Storage or on the data lake store is relatively cheaper than the same relational database store. So that's the first one. Second of all, when you load that data in, you typically want to store the raw data for further analysis later on. And again, the storage costs, but also whenever you then query that data, you also pay for compute. And the compute for a raw layer is not really necessary. You can do that compute, you pull that data in somewhere and then you do compute on it, whether it is on your local hard drive or local PC, or you have a VM somewhere or somewhere else. You pay for the compute as you're processing. But if you do that in a relational database instead, you have a higher cost of both compute and storage on top of that. So it doesn't really make sense to use the database end to end if you have a data lake or raw layer for self-service analysis and data science approach and need. If you're just doing data warehousing, fine, no problem. You don't need to do that. But if you do have a data science approach in mind, I would definitely say that it's a lot cheaper and more effective to do it in staging through CSVs or Parquet files and up to a database later on if that is what you need.
Okay, thank you, Mitesh, for that question. We have another one from Felwark. In your experience, what are the practical differences with building pipelines in Synapse versus Data Factory? Do you think that Synapse will gradually dominate Data Factory?
Well, pipelines in Synapse are still not 100% mature, but look for Catherine's session tomorrow. I can't remember what time slot she is in, but Katrine Wilhelmsen is doing a session on Azure pipelines or Synapse pipelines. So you can look at how it looks, but it's basically the same thing. So there's no huge difference in them. And then if Synapse will gradually dominate Data Factory, no, for the simple reason that there will be third-party needs. For instance, if you don't want to use Synapse, you want to use Databricks instead, or you don't need Synapse because you're only using a SQL database because Synapse is pricier than just plain Data Factory and SQL DB.
Well, thank you. And as you mentioned, Catherine has that talk tomorrow at 6 p.m. So that's Pipelines and Data Flows, Introduction to Data Integration in Azure Synapse Analytics. So with that, we don't have any other questions from the audience, but I have a quick one if we do have some more time. So my question is to you, have you encountered any challenges with regards to sensitive data? And if yes, how did you approach access management for the data, and who or what was responsible for that?
Yes, I have encountered. It depends on the use case and what kind of sensitive data we're dealing with. Are we just dealing with HR data that you have a valid reason for storing? Or if it's business sensitive data that you just need to protect from parts of the business or outsiders? Or if it's personal identifiable GDPR aspect kind of data. So all of these have different patterns on what you need to think about. HR and business critical data normally will be you restrict access on, you typically divide the data lake into a raw, into a sensitive and non-sensitive area, and then you tighten down on top of that folder, and then have a separate access controls on the catalogs or the folders underneath, depending on what sources you have. So you can fine grain that, as well as then doing encryption at application level on files that are extra sensitive. When it comes to GDPR kind of data, you also need to have knowledge of what data you have about whom, where, and what is being used for. And you need to also know how to be able to handle GDPR insight requests and things like right of deletion, right of rectification, or right of stop processing. And that is various techniques to do that, but one of the main thing is, again, make sure that you have logs and you analyze your data, and you have your data in the metadata catalog. And of course, data catalogs can also have access control on them, so sources can be so sensitive that you don't show them to regular users. But that control, as well as building triggers into your pipelines to make sure that you can run a pipeline to find that data source and delete the person from that file, typically.
Yeah, well, thank you. Makes sense. And looks like I have to work a bit in order to get control of that in our project. So that was very helpful, and a great talk from you as well. So thanks a lot to you, Johan, and to your questions in the audience. We'll take a short break, and we'll be back with Heini and a new host at 7 p.m. on the hour. So thanks for tuning in, and see you soon.
Hi everyone, and welcome to Global Azure Norway. My name is Oddbjørn Bakke, and I'm part of the .NET user group in Norway who are organizing this event, and I will be your host for this session. If you have any questions during the talk, please use the chat to post them, and I will include them during the talk. And here's our speaker for this session, Heini Ilmarnen. So without further ado, the stream is yours.
Thank you. All right, perfect. Good evening, everyone. Greetings from Finland. It is so bizarre at the moment. It's so light out, but it's still already getting a bit later here. And I'm still kind of in the winter zone a little bit and getting used to it being so light out, but it's kind of exciting. So this evening in the session, we're going to be going into Azure Machine Learning and into how do you get from first building a machine learning workflow within the designer in Azure Machine Learning, and how do you take the steps into starting to use notebooks, and when do you do that? So that will be our plan today. So this is especially aimed for you if you're just getting started with Azure Machine Learning, you maybe haven't done anything with it, or if you're looking to get started in using the notebooks as well. So why all of us are looking into machine learning, it is because we have so much data nowadays. We have all different types, from photos to streaming data to more structured data and databases. And what we want to do to that data is, of course, in the end, get some kind of insights. But to start with, we need to do some cleaning and prepping to make sure that we can even trust that information that we get out of it. But the ultimate goal there, why we even do that cleaning and prepping in the meanwhile, is because we want to draw some kind of, start training some kind of algorithms. And from those algorithms, what we want to find out is we, for example, want to predict something. We want to be able to see ahead of time what could be the predicted outcome, and from that draw value for that data that we have gathered already. And luckily, we have some easy ways to get started. And one of those is the designer within Azure Machine Learning. And what that really allows us to do is to just drag and drop all these boxes that allow us to build the workflow that we wish to achieve, from just grabbing our data set, doing any cleaning and preparation that we need, then splitting that for our machine learning training, and then getting all the way to checking how good is this algorithm that we just built. And so we have all these possibilities to work with. And this means that it is really, really easy to get started. It doesn't take much effort. We just grab our data and roll with it. It is also extremely fast to build our very first pipeline. And we'll take a look at that in a little bit. And the nice part here is that we don't need any kind of code. We don't need to pick up a new skill, etc. But we do need to know, where do the limitations come in using the designer? How far can we go? And what would be the next steps to take after you have started working with the designer? So I'm Heini Ilmarnen. I have my old introduction slide here. I have no idea how I did that. But I work as a DevOps consultant at Polar Squad. I used to work as a solution architect around Azure. My favorite topic is pretty much still architecture, even though I do things with a little bit more of a DevOps twist nowadays. I also run Azure trainings. I am a Microsoft certified trainer, and I studied to become a math teacher. And so I'm a bit of a math nerd at heart, and all the logic that goes behind machine learning algorithms is really close to my heart and is an exciting topic in my opinion. And so, as you might have already noticed, I'm a bit of a doodler, and that's what we'll be seeing during this session as well as some hands-on portions as well. So to get started today, we're going to kick off by getting started with the designer in a very quick manner. So before we head on kind of hands-on and hop into Azure Machine Learning and start building our first setup, I just want to give you a little background. So when we start working with Azure Machine Learning, we have kind of 3 different options that we can start working with our data and start building our machine learning algorithms with. And so the first one of these is the designer within the Azure Machine Learning services. And this does give us that really easy to use graphical interface where we can drag and drop things and just choose the tasks that we need to do. But we also have the option of using notebooks. And these give us a programmatic way of working with algorithms, and it does give us more flexibility. There are more options for us to use with. And then lastly, we also have automated machine learning. And this is where there are these mechanisms built behind the scenes where it will run through different scenarios, and through that help us choose the right algorithm. But today we will be mainly focusing on the first two, and first starting off with the designer. And so we're going to hop right into it and build our very first experiment here. So let's go. All right, so I have already beforehand created a machine learning service in Azure, and you can go in and do that yourself as well. And we're going to launch the studio, which is actually a separate graphical interface to use from the portal itself. So it will direct us here. And right from the beginning, we can notice that there are these three different options to work with. We have the notebooks, we have the automated machine learning, and we have the designer. And we're just going to start with the designer because that is the easiest place to start. And it'll kind of get us accustomed to the process of building these machine learning pipelines. What are the steps that we need to do? So we're going to go into the designer. I'm going to navigate from the left here, and we are going to start a new pipeline here. So the designer experiments that we build, they are called pipelines within Azure Machine Learning. So when I create this, it automatically starts to ask me some questions. What kind of things do I want to use here? So I can give it a slightly better name. So let's do global Azure. And then it also asks me to select the compute target. So we have to select where does this run? And I have created one of these beforehand. This is a cluster that I specified earlier on, and I will show a little bit more about that at a later time. Also, if I wanted to set some parameters, etc., I could do that. But right now, this is kind of enough for me to get started. And so to get started with our experiment, the first thing we need to do is grab our data. What kind of data do we want to work with? And in this case, I have brought in already one data set, which is this open data set that is available to look into aspects of how can we determine whether someone is prone to having diabetes. So this is what this data set is telling us. And the nice thing here is right away when we have connected to this data set and dragged it onto our graphical interface, we can look at the output and visualize this. So we have this very easy way to get started and see what has this data actually eaten, what's in it. And once this opens it, I can see kind of a sample set of values from this data set. And I can see that we have age information, we have the sex, we have the body mass index, and then the rest of these values, they're not named very clearly. So to understand this, I had to go back to the information about the data set. And the rest of these columns are actually telling different blood measurements. So these are just different values that can be measured from the blood. And then as the last column here, we have the Y column, which is kind of a number that says how prone are you to get diabetes. So first of all, to start with any kind of machine learning, even testing around, experimenting, we should have some understanding of our data, because without that, it's kind of hard to even know what could we predict and which of the columns could we use to do that. And so in this case, we're going to start predicting the Y column because we want to predict, well, how likely is somebody to get diabetes based on these other values. And since I'm kind of starting off, I just want to grab all the columns, and then I could do some adjustments and test with different combinations as well after the first results. But we're just going to start in that way. So here we have wrapped our data sets. So we have to figure out next what would be the next step to take after this. And so in a lot of cases, what we want to do is, for example, to select some columns. So for example, we have this data transformation section here where we can find different tasks that can be done here. And for example, I could clean some missing data. I could also, as I said, select some columns, and that's what I'm going to do in this case. And we're just going to drag it there. It gives us kind of this editor right away that we can use. It asks us to which columns we want to include. So we could do include all columns, but then exclude one of them. For example, by the name. And for example, I could just say S3. That was one of the columns. But in that case, let's just do the first run with all the columns. So I'll just have this as a placeholder to adjust at a later time. So right now it's choosing all of the columns. And then when I'm done with kind of the definition and configuration, I just drag an arrow to tell, well, grab the data from the first task and give it to the next step here. As the next step, we want to split our data because we want to have some of the data go into training our machine learning algorithm that we choose. And then we want to split the other part of the data to use as our test data set to then look at the scored model and check whether it's accurate or not. So I'm just going to put it so that we get 70% into the first data set and 30% to the second data set. And I'm just going to leave the other values as they are. And again, I'm just going to drag the arrow there. So then this first portion of the split data we want to take to our machine learning algorithm. So let's just, so we can see this list a little better. So we want to do model training. We want to train the model from this data. And here we need to specify the label column. And here it's going to be the column Y, which was the last column in our data set. We're going to save that. There we go. And we're going to just take this first data set and drag it to the training the model. And now we're kind of missing the other aspect of this training the model because we need to tell it what model are we training this data set against. So we're going to choose the linear regression here. And sometimes if you can't figure out like which category is it in, then you can just write in here linear regression, and it will tell you, give you some of those options. So when you choose linear regression in the designer, it gives you two options. You can use the online gradient descent or ordinary least squares. And of course, to know which option would be the best, you need to have some understanding of the different algorithms and the kind of data that you have. And then, of course, one option is to just test around and see what would bring good results for you. So we're just going to go with the kind of the default settings in this case. We're just looking to build our very first try here. Let's move that out a bit. And that is the other input that we're taking in to train our model here. And so after we have trained our model, the next step is then to score and then evaluate the model. So first we're going to score it. So that is where we are going to see whether the results that we have gotten from this training of the model, if that model that we got out gives us good results. So it will kind of calculate all those results that we would get. So we're going to drag that in there. And the other input that we need is the other portion of the split data. So that's what we're comparing against. And then when we've done those comparisons, then we can bring in the evaluation step. And again, we're just going to drag that in there. And here we actually have now our first first pipeline. So we're bringing in some data, we're selecting columns. Here we didn't yet drop any, but we could in the future. Then we're going to split our data to the one that we use to train the linear regression model. And then we split it to the one that we're going to use to score the model. And then once we've trained the model, then scored it, then we're able to get these evaluations out of there. And so then we're ready to submit this. I'm just going to click submit. It's either going to ask us to select an existing experiment or create a new one. I'm just going to create a new one here. Well, let's do that. And on the first run, it can often take a little more time than in the future it will when you do subsequent runs on this. And it also depends on whether the compute has had time to shut down, for example, in between. So while we let that run, we can already see that it's going through the different steps and even saying that it has been able to complete, for example, the selecting of the columns, but it is right now starting to work on splitting of the data. And as it goes along, we're able to go through this and, for example, look at the different visualizations at the different steps. This is the very first one that we looked at. And for example, if we wanted to look at what kind of age values we have, it will give us all of those kind of central tendencies of what is the average, what is the minimum and maximum, etc. And we'll have kind of more information about how our data is spread. And one kind of essential information here is also the missing values. So we know that we actually have no missing values in this column. And if we were to click through all of these, we would actually see that none of these columns have any missing values. So we know we don't need to handle those in any way, which in a lot of cases we might need to even. So that's going to take a little time to run. So we're actually going to take a little shortcut. I have a previous run here, there, and we're going to look at the results here. So it's pretty much the same setup. I had a clean missing data step in here as well, but as you could see, we weren't missing any data in the first columns, and I checked all of them and there was none missing. So pretty much the previous pipeline was the same as this one. And so now as we're going in through this, now if we look at actually the train model step, we can actually see that this will output a trained model. So this is actually the step that outputs the specific model that we have created. That's where the output comes from. And from that output, using that one and the other data set, we are now able to look at the scored data set here. So we can see that it looks very much the same as previously, but in addition to the regular columns, we also see this scored labels one. And this is showing the predicted value for the Y column. And if we kind of just eyeball through that, we can see that, yeah, some are somewhat close, like these ones, but some are kind of quite far away. So there is some kind of variation there. And just by looking at it, we can see, well, some are closer and some are quite far away even. So it might not be our best attempt yet, but to really know how good it is, it makes more sense to look at the model evaluation. And then there we can, for example, find the mean absolute error and the root mean squared error. So these are the different ways to describe how far away are the values from the actual value of the data. How far away is the predicted value from the actual value? And this is in the kind of, we had that Y column value, so it's like 53 away from the actual value on an average. So that's kind of what that is telling us. And to understand really what that means, we need to, of course, understand about that Y column. How big of a difference is that? It depends on the scale of that number system that is used in the Y column. And unfortunately, I don't know those exact details. So we would, for example, need to go back to somebody who is the subject specialist to learn more about that. And we have also these other values here. So the relative squared error is 0.42, for example, and the absolute error is 0.61. So that's our results. We have built our first designer pipeline here, and our running one will be done shortly. But in the meanwhile, we're going to continue on to the next topic. So starting with a designer was quite easy. We could just drag and drop. It was kind of intuitive as long as we kind of know what are the steps that we need to go through. But for example, when we were choosing that, starting to run that pipeline, it, for example, told us that we need to choose a compute, we need to specify a name for experiment. So it's kind of telling us certain things in advance. So yes, it's easy to start quickly with a designer, but if we want to start working towards using notebooks, we need a little more information. And so next we're going to look at an overview of Azure Machine Learning to understand how all these different concepts fit together. What are experiments? What is the compute doing? What are these different methods? So next we're going to go into that. Sorry about that. So if we think about Azure Machine Learning, so we have these three different ways that we can work in Azure Machine Learning. We can use the designer, we can use the notebooks, we can use the automated machine learning. And there are some differences between these different options. The designer we can only use within Azure Machine Learning itself in the graphical interface because it's kind of a tool set that is built in there. But for example, to work with notebooks, we can use work actually from our local computer. We can even use Azure Machine Learning from Synapse Analytics. If you were listening to the previous session, that was mentioned there. And also with the automated machine learning, we can work with that from different places. And that is due to the fact that these work through the Python and our SDK. So in whatever environment where we have those available, we're able to work with Azure Machine Learning as well. So we can set up a local development machine to work with Azure Machine Learning, and then it's even possible to run our experiments locally on local compute as well. So we start with these three different options to work with our data. And of course, the first thing that we need is some kind of data sets that we're going to pull in. And one aspect of Azure Machine Learning is that we can define different kind of data stores and data sets. And the data stores are pointing to things like Azure SQL or Azure Storage or external databases from things that aren't within Azure, but it's kind of a pointer to a specific data store. And when we do that pointer, when we set that within Azure Machine Learning, then the people who are working within Azure Machine Learning can also discover the data sets that can be found within there. And then we're able to also define these data sets, such as was this diabetes data set that we were working with in the example. That was defined as a data set in the Machine Learning Studio. And when we have that, it means that we can use that data set, that same exact data set in different experiments. And that allows us to ensure that everybody's working with the same data. It's not that somebody was able to pull a different set of data and another person pulled a completely different set. So we can have kind of these predefined sets of data within our Azure Machine Learning environment. And so when we pull that data into our designer pipeline or into our notebook, then when we define what we're going to do with that data, we need to run that somewhere. We need to have some kind of compute underneath against which it will run that experiment. So for example, for the designer pipeline that we just walked through, we had a compute cluster that it was running that whole thing against. And then as we go into our notebook in the next step, you will see that also for that, we need to specify a compute that we're running it against. And as I already mentioned, if you work locally with Azure Machine Learning notebooks, well, actually there are Jupyter notebooks, but if you're working with Azure Machine Learning with the notebook portion, then you are able to even run that notebook locally on your local environment. And the same with the auto machine learning as well. That can be run anywhere. But we need some kind of compute to run that on. And we can have those definitions within Azure Machine Learning. And this includes both the parts where we're training our model, but also when we're deploying it. So we can also define those deployment destinations where we want to take our model that we got out of our training and we want to actually publish it and have it used in our application. So, but when we're in the training phase, what we then want to do after we have all the steps in place and we have defined where will this run, then we will actually run that specific one, and this is called an experiment. So you saw that already when we were defining the designer itself. So those are the kind of the main components that is in there. There's more detail to all of this. So if you're interested, start digging more and finding out more about the different options. But those are kind of the components that we need to understand to be able to start working with the notebooks in a more efficient manner as well. So if we just take a look back at the designer that we worked with, yes, we can, if we go to the experiment section here, this is what we are running. We can now see the Global Azure Designer experiment here. And now we're able to go to all the runs that have gone underneath it. And if I were to make adjustments and run it again, I could see the different results and go back to them. So I can just click this run, and I am now able to see the results for this specific run as well. And I could, for example, go directly to the evaluation, which is actually still running. It's just in the finalization stage and will be done in just a moment. So you saw that's about how long it took to do that. But also what we were using here was compute. So here on the compute portion, we can find compute instances and compute clusters. And what we were running this against was actually the compute clusters. So this is what this particular designer pipeline was running on. And as you can see, one of these nodes is currently busy. So it's running our pipeline that we started a moment ago. And then the third portion here that we were using was the datasets. Here I had registered this beforehand, but we can create our own datasets from either just bring local files and get started really easily. We can use the data stores that we have defined. So for example, if we have the pointer to our Azure SQL, we can pull different datasets from there. We can grab some web files. And then the particular dataset that we were using is from one of these open datasets. There's quite many of these available here. So these are a good place to get started if you don't quite yet have your own data to work with. So you can just define one of these into your workspace as well. All right, but we are going to use all of these concepts as we start moving towards the notebooks as well.
So
here.
We have a question. What's
Perfect.
the difference between compute cluster and instance?
All right, so that's a very relevant question. So a compute cluster is where we're able to define a cluster that will have multiple nodes running. So then if you have a kind of a more complex machine learning algorithm and the model that you're training is complex and needs a lot of compute, then you can have a cluster and that workload can be spread out on that cluster kind of more evenly. And then when you have a compute instance, that is just one node. So that's the difference there. Perfect. All right, and perfect timing. So that is kind of the overview of the different components. And now that we understand these a little bit, it's going to be easier to get started with the notebooks as well. So as the third part today, we're going to get started with our first notebook. So as said, we will move on to the second portion here. And so we're going to get right to it here. So I'm going to switch over again. And I have kind of done a little bit pre-prep, so we have a little more time to really focus on the kind of details and why we're doing each point here. So I have created a notebook beforehand. We're just going to navigate to our notebooks. As you can see, you get kind of your own folder where you can create your notebooks, and you can even share these with different team members. And so you can share the notebooks however you wish to. And so as we're starting to work with notebooks, if you haven't worked with them before, they're kind of this nice combination where you can combine both documentation, because you can have these text blocks as the first one here, and you can combine these code blocks as the second one right here. So, and as also when we open this, we can see that, yes, there is also a compute virtual machine here that we're running on. This is now the compute instance. So it's just one virtual machine. And since we're working with the notebooks, that virtual machine will have all the tooling in place that we need to work with. So it has all the tooling that we would need to put in place if we instead were working with on our local computer, for example. So I can actually show that pretty quickly here. So if we just take a quick look at the compute instance that we had connected there, we can see that there's Jupyter Lab, Jupyter, VS Code, RStudio, and the terminal installed as applications on this particular virtual machines. And so that means that we have all the tooling in place that we're going to need. So now we're going to start working through kind of trying to find the same steps as we did in the designer as well. And actually, in this case, we have to take a few steps back, and we need to start from actually getting the workspace configuration and connecting it to the workspace that we want to work with. So that's where we're going to start. My compute here is already started, so I can start running each of these cells one at a time, and I can even kind of click through the text fields as well. So if you haven't done this before, you can just use Shift-Enter to navigate, and that will run the code blocks, and it will just kind of skip the text blocks instead. So in this first block, I am going to use some of the Azure ML Core libraries to be able to connect to our workspace and do the interactive authentication in there. Now, since I'm already in this workspace, it's not actually working locally, it would ask me to sign in. As the second step, one of the steps that kind of came easily in the designer, we just typed in the experiment name, is that here we need to either connect to an existing experiment or create a new one. So I don't actually have an experiment for this one yet, but it would kind of notice if I gave a name that already exists, and I could just run it again in that way. So I'm just going to run that, and it will create that experiment in the experiments set. Next, I am going to connect to our data set. Here again, I'm going to not actually use the data set that we had defined within our Azure Machine Learning, but I'm going to directly connect to the open data sets. So again, I'm going to use the Azure ML Open Datasets library, and within there, I can just import the diabetes dataset by referring to the diabetes dataset with the import. So I'm just going to get that tabular dataset and import that into a data frame. So that's what I'm doing here. And so what you notice here is that the coding itself isn't very complex. We're not doing selects or anything like that to get things, but we need to know which of the libraries we need to reference to be able to run these actual code blocks. So for example, here previously we needed aspects from the Azure ML.car, and here we needed the open datasets as well. And now that we have imported this diabetes data into a data frame, we have different ways in which we can kind of figure out what kind of data we had. So in the designer, we had that nice graphical interface, and we could see these graphs and see different values about it. But here we have to work a little differently. So just to figure out how many columns we have in general and what kind of values there, we can run the info query. So there we see that we have the same columns as we saw before, and we can see the different types. So we have some integers and also some decimal numbers as well. But if we want a little more information, we need the describe here. So this is where we kind of get similar to what we got before. We get the mean value, we get the standard deviation, we get the minimums and maximums, and also how the data is spread out. And so we get a little more information. And here we can see that all across we have 442 rows. And if we go all the way to the right, we can see that that applies everywhere. So I'm going to scroll this up a little bit. All right, so now we are able to get a general understanding of our data. So out of the box, we don't get any nice visuals. If we did want that, there would be ways to do that as well, and libraries we can use to make that work. But just because we have a bit of restricted time today, we're not going to go into that detail. So next, we're going to start prepping to split our data. So next, what we're going to do, we are going to create two data frames, the X data frame and the Y. And into the X data frame, we're going to take the entire data set, and then we're going to take the Y column from the X data set and move it to the Y data frame instead. So that has been done. And just to ensure that that's actually what happened, we're just going to run the describe again against the X data frame, and we can see that we have all those columns.
Sorry.
Yes.
Is there something wrong with your picture? We get a question here that there might be the wrong picture on the screen.
Yes, you have the wrong picture on the screen. I am so sorry about that. Thank you for pointing that out, and I apologize. Two screens, first time I've done that particular mistake. All right. Okay, how much time do we have? All right, I'll do a little recap of what I was trying to show you, because apparently that was not moving. So in the first portion, we're connecting to the workspace. I'm just gonna hop over here and we're going to run through these blocks one by one really quickly. And so you know what I was showing previously. So again, we're going to use the Azure ML.core libraries and connecting to our workspace. We're then going to connect to our experiment that now actually already exists because I ran this previously already. Then we're going to get the data set from the Azure ML open datasets. Then I'm going to make this just a tad smaller. We're going to get the diabetes data frame info, which is actually this one. And then we ran the describe, where we got much more information actually. So this is where we get all the means and standard deviations, etc., for all the different columns. So this is kind of the similar that we were able to get from the visualize step in the designer. And then this is where we kind of got to the fun part, where we actually split this diabetes data frame into two. So we did the X data frame and the Y data frame. And if we kind of double check with this X one, we can see that we no longer have the Y column there. So we have all the other columns but the Y. And then when we just, oops, this is popping kind of weirdly. When we run the describe on the Y data frame, we notice that we have just one column where we get all this information from. So we again get the means, etc. So then we need to split our data into the training and testing data set. And this was pretty easy in the designer. We just dragged the split data task and just put in what portion we wanted to do. But here we are going to leverage the scikit-learn library. So that is one of the libraries where you can find a lot of the things that we're going to need for machine learning tasks. We're going to find this train test split, and in the next steps, we're going to, for example, grab the linear model one, and then some of the metrics that we're going to need to be able to evaluate whether this model is working well. So we're going to do the splitting of the data. There's this train test split that we can use, where we give the training data set, the testing data set. No, wait, sorry. I got myself confused with this screen thing. So we give what we're going to split this into is these 4 sets. So we're going to get our X training set and our X testing set, plus our Y training set and Y testing set. And the X here is going to contain all the columns that we're using to train the model. So it's going to include several models. So that is actually going to be a matrix format. So if you're interested, you can look into that, what that means. But it's going to include all those columns. And the Y sets are going to only include that one column. So to do the split, we're just going to input the X data frame that we already created and the Y data frame. And then we're going to give it how large do we want the test size to be. And here we want to use 0.3. So in the designer, we told it to give the first data set as 0.7, so 70%. And in that case, that was the data set that we took to do the training. But here we're specifying the size of test data set. So we take the 30% instead, so 0.3. So we're going to run that. As you can see, that was a fast task. And then next, we're going to grab the model that we want to use, and then we're going to train that model. So in this case, we're going to use a linear regression model. And here kind of comes the difference between the designer and using the notebooks. So within the designer, we had just 2 options for different linear models that we can use. But actually in the scikit-learn library, we can use many, many more options than just those 2 for this case. But we're just going to go with the basic linear regression as we did in the designer as well. And so in this first line, we're here going to just specify what is the regression that we're going to use. And then to train that, we're going to use this fit where we specify then the data set that we're going to train and then the results of the Y column that were in our data already. So we're going to give them both the X and the Y values. And then after that, in this next step, this is where we score the model. So this is where we give it the test data set, and we're going to see what does it actually predict out of there. So let's run this. Didn't take long at all, again, as we could see. And then as the last point, we need to get some kind of similar information as we got in the end of our designer as well. How good is this model that we created? So we're just going to grab some of the coefficients that are easy to get out by default from the library. So the mean squared error and the R2 score. And so we're going to get the regression coefficients. So these are going to tell what our algorithm is like actually. So these are the values from there. The mean squared error is telling us one of the similar values as we could find in our designer. So I'm just going to show you the comparison in a little bit. And then we have the coefficient of determination here as well. And so I'm just going to grab the designer out real quick here. And we're going to grab the one that we ran in just a little bit ago. And if we go into the evaluate model section, we can see here that it gave the root of the mean squared error. So here we got the mean squared error instead. So we would need to take the square root of this to have the same value as we had there, but this is actually a little bit over 50 as well, 52, 53, somewhere there. So we're very, very close to getting the same answer. And here we have the coefficient of determination at 0.52, whereas here we have it at 0.56. And where these differences can come from is because we're splitting the data, and actually the designer and the notebook can be splitting the data a little differently because there's some randomness to it. And the other aspect is I didn't go into all the little details to ensure that they are like exactly to the point the same. But we did have all the same, very similar steps in here. And as you can see, we got very similar results as well. So we have actually now gotten to a point where we have been able to build our very first notebook here. And so what we really were doing as we were working through that notebook is that we were kind of looking at each step at a time. So if we, for example, take one step out of the designer as an example, the split data step here, and we think about how do we do this in the notebook? Well, in the notebook, actually, we needed to take 2 steps. It wasn't just one easy step. So we first split the data frame itself. So we had the data frame where we have the columns that we're using to train the model, and then we have the data frame where we have the value that we're trying to predict. So we did that first. Those are the 2 first lines here. And then as the second portion, we had the actual splitting of the data, where we needed to have both of these data sets separated already to be able to do that split. So kind of, if we work starting from a designer, it actually allows us to understand the phases that we need to have within our notebooks as well. And we can use it as a comparison of like, have we done all the things that we needed to do within our notebook to get the results that we wanted. So that can really help us work as well. So it's not a bad place to start with the designer. So that's pretty much why we started today with the designer. We kind of put together a simple pipeline where we use the linear regression to determine, to predict this value of y in our data set. Then we took an overview look at Azure machine learning, so we could understand the compute and the experiments and the data sets that we can use in our notebooks as well. And lastly, we then wrote actually our first notebook. And it wasn't that many lines of code, but yes, there are some things that are more simple in the designer, like the visualization aspect. And there's some steps that are kind of even easier within the notebooks, like the training itself. It's just 1 line of code, and that does the trick. And even we could see that it was really fast, faster than in the designer setup. So now that we've gone through these 3 different steps, the next time you go ahead and grab your data and you start working with it, you want to start doing some predictions. You're able to start doing the cleaning just as well in the notebooks as in the designer as well. And when you're getting to that point of training your machine learning model, then to get those insights, you have now an idea of where to go to make those steps within notebooks as well. So I really hope you enjoyed this session, and it kind of gave you the first steps to get started with to start moving towards using notebooks as well. As said, designer is a great place to start with, but you have less algorithms to use, for example. So there are the most common ones in there, but you don't have all the expansiveness that you have within the notebooks and leveraging the different libraries that are available. I also wanted to point out that during the Global Azure event, there is this 30 days to learn kind of campaign. And if you want to take part, there is actually a data science track where you're going to get a chance to build machine learning pipelines. I'm not sure if it's just the designer or also the notebook, but if you want to get deeper into this topic, it will be really kind of a good place to start, where you'll have kind of these learning tracks that you can use. So grab those links and get started, and you can get this learner badge by completing one of those. Only word coming to my mind now is experiments, but I don't think it's an experiment. But you can complete one of those tracks that is available on that page, and you have 30 days to complete it. So thank you so much for joining. If you have any questions, we have some time for Q&A, and if you have any further questions after that, you can also find me on Twitter as well. So thank you for joining.
Yes, we have one more question here from Mitesh. Giving you real-world experience, I am am I correct to state that small, medium-scale companies generally use notebooks for machine learning?
Yes, I have to say I haven't seen much designer setups used in full-on production mode. So as you could see, like the designer setup we had took quite long to run, but the notebook code blocks, the training took like 1 second to run. So that speed difference is something that's there. But also if you're starting off with the designers, you can kind of get those experiments in really fast and kind of just figure out, can I even do anything with that data? So it's kind of an easy, fast starting point. And then you can kind of, once you've figured out what you want to do, then you can kind of take that over to the notebooks as well. So yes, notebooks are more common, I would say.
So there's another question from Mitesh. I am new to Python, R, and Scala. Which language do you recommend I learn, or what language has the least learning curve?
So as mentioned, within Azure Machine Learning, there's the Python and R available. So from that perspective, I would say Python or R. And with least learning curve, this might also be a bit of personal preference as well. But in my opinion, Python does have a bit of a less of a learning curve. So R is very full on like data science, deep in it type of language. And Python is something that is used also in other contexts rather than just machine learning. So it's also kind of useful to other coding areas as well. So it's not the only place you can use it. So I would say start off with Python. It's kind of easy to get started. There's the libraries that are available there are really useful and powerful. So it's a good place to start.
Yeah, and then I don't think we have any more questions.
Okay, perfect.
So, it's an interesting talk.
Yeah.
Thank
it
you.
was fun.
Yeah.
And thanks for chatting about the screen share. That worked out fine in the end. So
yeah.
All right.
Yes.
Thank you, everyone.
Last question.
Oh, last question.
Mitesh now also. Any good books you recommend one should read to understand generally used ML terms?
Yes, if I could just remember it right at this moment. There are good machine learning books out there. I think I can pop into the YouTube channel and write that in the chat in a moment because I can't remember off the top of my head. So that might be a good solution here.
That would be great.
Perfect.
Yes. All right.
Nice.
Yeah.
Thank you so much for doing the questions during the session. And thank you for having me. It was a great to be part of this.
Yeah. Thank you so much, as they're saying. So very helpful. Great.
Perfect.
Bye.
Bye.
Hi everyone, and welcome to Global Azure Norway. For any newcomers to the stream, my name is Oddbjørn Bakke, and I am a part of the .NET user group in Norway who are organizing this event, and I will be your host for this session. If you have any questions during the talk, please use the chat to post them, and I will include them after the talk. And here is our speakers for this session, Goran Vuksic and Kim Hedberg. So without further ado, the stream is yours.
Thank you.
Thank you.
Good evening, Norway. It's super exciting to be over here, right, Kim?
Yes, absolutely.
Yeah, so shall we start?
Let's do.
What do we talk about?
Yeah, we're going to speak about AI, how to use AI to create smart sales. And this talk will be combining business and technology.
So we will torture them with business first, and
Yes.
then we show some code, right?
Exactly.
Yeah, that's the plan.
So-
Awesome. Let's do it. So who we are?
Yeah, my name is Kim Hedberg, and I work as a manager for strategy and offerings at Stratitech, an IT and business consultancy based in Malmö, Sweden.
And Goran Vuksic. I work as a technical manager for Stratitech.
Yeah, I already said that. So you can skip to the next one.
So it's fine. Okay.
It's fine. Yeah. So let's start with the business part, because that's basically what I'm here about. So you all know that data-driven is the new black, obviously. We've been through digital transformation for the last about 10 years, working with everything from digital marketing, digital business as such, e-commerce. We've spoken about omnichannel, big data, everything connected, shifting to the cloud. And now, obviously, our AI is coming into play as well. And all of this has given us tons of data. And of course, that also means that we are now able to go to the next step and be more data-driven. So this is basically what we're trying to help our customers do and become. So what are the drivers to become data-driven, except for the digital transformation, which is obviously creating the capabilities and the data at hand? We have, everything is getting more and more connected. We have both 5G, but not the least, we have Industry 4.0, which is driving the connection within industry manufacturing specifically at large. We've also seen a lot of changing behaviors during the last years. It's been, starting with the consumers and customers changing and getting adapted to that, which we took with us to our professional lives. And we're starting to ask for the same type of services that we are expecting as consumers. But the whole society is also changing, and we're actually ready to do so. We're almost expecting things to be smarter and so on. So it's a natural behavior for us now. And then last but not least, we have the cloud democratization. So if we previously had to invest a lot of money to get computer power and have access to data and so on, obviously the cloud is now making it possible for more and more companies to use the benefits of the cloud in terms of the latest technology, AI, real-time data, and so on. So that's very much driving the shift towards being more data-driven as such. But still, we have 86% of B2B companies saying that they can do much more with the data they have. So what does it actually mean then to be data-driven? Take the next slide. So we speak about three different parts. We speak about decision intelligence, so being able to make smart decisions based on data and insights instead of gut feeling. We speak about data-driven competitive advantages, so actually leveraging the data and using it in a strategic manner. So either you could increase your revenues or you could increase your efficiency, for example. But then it's also about a way of being. It's about creating a data-driven culture. So it's very much about people and processes combined with technology, leadership, and culture as such. So it's shifting not only the technology and the way we do business, but also the way we work together and how we view our reality, so to say. But becoming data-driven is not just about technology or business. It's very much about all three perspectives. So we need to have the business part of it, obviously. We need to know that it brings value in different ways. We need the technology to be able to help us achieve it. So we need to have that modern platform architecture. But then we need to adapt processes and create that data-driven culture to be successful. So all three perspectives always have to be in play.
So what would reasons be for a company to become data-driven? Well, we've talked about it earlier. So we want to be able to make the smarter decisions always. So those decisions could be made by us as persons, but it could also be done by machines. So machines could take the decisions for us, proposing what the next action is to take and so on. But we want to be able to make those smart decisions instead of using gut feelings. We also have the possibility to create new revenue streams. We have tons of physical products that are now being connected with sensors to be able to create smart products instead, where we can use the data and create services, which could then in turn create new revenue streams, where we have subscription-based business models, for example, where customers can buy services and so on as well. So it's really creating possibilities to get new revenue streams. We obviously want to bring all this data we have back to the customer as smartness. So be it new services, but also new products and new ways of working. So not just saving the data for yourself, but actually being able to share it with your customers. We want to predict instead of being surprised. I am sure that many companies, when COVID hit last year, had to make a lot of decisions where they actually weren't possible to predict what the outcome could be, because they've never been in that situation. But they also had to take decisions very quickly, and could then, I would say they would be surprised anyway, because obviously nobody expected a pandemic, so to say. But still, they might be more surprised, but could have seen things happening on the way. So being able to predict new customer behaviors and so on is something we want to do instead of being surprised. And then last but not least, we want to be able to capitalize on the digital investments we've already done. So basically, we have a lot of data. It's sitting in our books, but it's not really visible on our balance sheets, for example. So how do we actually capitalize on that and make it worthwhile and create business value for it? So how do we make our data work for us? So tonight we're talking about AI for sales. So let's deep dive into that part. So I just read this McKinsey report. It is from 2019, but I stumbled upon it last week. So a third of all the sales and sales operation tasks can actually be automated, but only 25% of businesses have started. So we could work with lead generation using chatbots, for example, to handle customers that get stuck in different funnels. We could work with churn prevention and identifying risk customers with machine learning, and then help marketing to activate really targeted actions. We can speed up the request for purchase process by being able to identify questions with natural language, for example, and then provide the answers automatically. We could optimize the customer journeys with RPAs, so being able to streamline the process from order to cash. Or we could also work with product activation, for example, activating licenses if you bought software by using bots. So there are several possibilities where we can use AI and machine learning actually to increase sales. So a couple of examples then. Data-driven sales forecast is something that our clients are looking for to a large degree. It's always sort of a fight between sales and operations. So sales are selling and operations need to produce whatever needs to be sold. And obviously operations don't want to have stuff on the stock, but actually produce the order as much as possible, while sales want to be sure that they can deliver in time and know that the customers can get what they want. So how do we optimize so that we actually have a data-driven sales forecast, and what business value can it drive? So we will have if we succeed in making the sales forecast better and more data-driven, we will have a cost optimization. So it will be more cost efficient for both operations and supply. We can have more of an operational excellence. So being able to plan smarter and have better forecasting and automation. The customer experience will improve because we will have more accurate forecasting. We can also ensure faster deliveries and better service. And it also drives an organizational alignment between the different parts of the organization, where you have to work with common data definitions and share the responsibility for this between sales and operations. And not the least, you actually get reliability. So the forecast is based on facts and insights rather than guesses. And that creates trust in data. So when we work with this, if you take the next slide, Goran.
Sorry.
No problem. So this is just a visualization in Power BI in this case, where we've created a solution where we define the data sets, obviously, and here we are combining different data sources. So we're using historical purchasing data, but we're also using data from the CRM where we have different opportunities. So being able to predict future sales based on the opportunities together with historical purchasing data. And then we add external sources as well. So it could be trends, it could be reports about how much a certain industry is expected to deliver, or how many new types of products, new vehicles, or whatever it could be will come. So we can add several sources and thereby base a more accurate forecast based on those data. And then we use Azure AI and machine learning for prediction. And obviously, we also have to add the ability to actually be able to make small manual adjustments, because there will always be something that happens ad hoc, or deliveries that are not occurring, or something else that's happening on the way. So we need to have that possibility. And then we visualize this with Power BI. So making it easy for both operations and sales to see what is going on. So this is a very valuable feature for most companies, actually. Another area where we're looking at data-driven sales is actually to use the transactional data and machine learning to optimize sales. And this is very applicable, for example, for companies that might be B2B companies, mostly, I guess, that doesn't have maybe an e-commerce solution, are not driving sales that way, but they can actually, by thinking more like an e-commerce company, they can use the same sort of data to predict what's the next best purchase, what should we recommend, how can we create smartness based on the order history of this specific customer in combination with the products we have available, and so on. So you can use the data you have, both transactional data, but also what you have sort of in stock and other types of data in terms of delivery time to the customer and so on, to create a smartness where you can help your salespeople then know who to call first, basically, where you would have a greater success rate in converting the customer to sales. So yeah, you can take the next one. So this would be a solution where we've taken data from, as I said, order history, stock availability, and actually delivery time as well, because in this case, it's a customer who is turning over their stock quite quickly because they're in a fast-moving consumer goods area. So we're using that data to create an algorithm, and then putting an algorithm on top of it to be able to create which customers should the salespeople speak to first. And then we use Dynamics 365 to show the results and guide the sales agents and Salesforce and key accounts on who they should address to get a more data-driven sales, so to say, to be more successful. And then we're getting into the last example, which then Goran will show you how it's done in a demo as well. Here we're looking at an AI-supported sales and customer service where we are using voice recognition. So this is the business value we can deliver here as well, is an increased customer satisfaction. So when we speak to the customer, we will be able to give them an offer with the right product, price, and the right delivery time. So that optimizes the sales opportunity for the customer and obviously for the company as well. It will increase sales efficiency and margins because we will also suggest the right price. So we can help the salespeople offer the best price where they have the highest likelihood of getting a conversion, but still keeping the biggest margin for the company. We get a reduced operational cost because we get a faster stock turnover, for example. And then we can get real live insights. So as we sell, the data is updated. So we always know what we are offering based on what's available in the stock, for example. Please take the next slide. So the solution here is that we used voice technology, and then we are empowering the sales agents when they're speaking to over the phone with a customer. They get smart suggestions based on what they're speaking about. So we can custom tailor the suggestions based on the conversation, whether it's what product they are discussing, if it's price discounts, what we have available in the stock, and so on. So Goran will show you later on how the suggestions are changing based on the conversation. So I think that was all from the business part, which I've now tortured you with. And I will hand over to Goran to show you the good stuff then.
Yeah, but we had to say a bit about business because there's technology is technology without the business. We need to purpose to develop the apps and help out the clients achieve some things. Kim was a bit shy. I'll introduce myself on my slide to say a few words. And bit of background. Let's start when I was a kid. At some age, I think I was 5, 6, maybe, I wanted to be a pirate, and not a software pirate. I the ships and guns and eye patches and cannons and such stuff. And I was thinking why I don't live in that age of human history. And later on, probably inspired by Indiana Jones movies, I wanted to explore the jungles, and I was thinking, yeah, but like everything's explored, everything was on map. Why don't I live in that age of human history? And as I was growing up, but this was changing over time until I figured out that we actually live, we live all together in the most exciting age of human history because of technology and what is happening around us. And like, if you take a look, like open any TechNews portal and you see this company did that, this company, that company did something else. And it's really amazing. I was always imagining like this smart robots being able to talk to some kind of robot and such. So I guess that's why my interest in AI, and somewhere on the way I got this Microsoft AI MVP title. I got some 15, 16 years of work experience in IT, worked on a lot of different technologies, programming languages, and such. And I like to attend different conferences, do workshops, and write blog posts. I'm tech enthusiast, and that's me. So let's start with our session from the bit tech point of view. And just to continue what Kim was saying, like, we talk about AI and smart sales, and you are maybe familiar with this guy, Michael. He was running one company that was called Dunder Mifflin Paper Company. They were selling paper. It was around, I think, 15 those sales persons over there. They were constantly on the phone, right, and trying to sell. And not all of them are the best salespersons, I would say. They will try to modernize their sales process. Somewhere on the way they introduced web page, but it didn't really work well for them. So how, if you imagine such company, people are on phones, they are selling, they do have a website, they are doing this because they want to keep personal touch with their client, and their client wants to keep personal touch with them. They could order on the website, and they could chat with some chatbot, but not everybody likes to do that, right? There's still a lot of companies that are doing this phone call sales. So how could we empower them to actually perform their daily job better, to be able to make more sales, to know the customer better, to give them offers that they actually need, and such things. So yeah, that's our scenario that we will go through today. So when we talk like about how we develop projects and how we sell those projects to our customers, it works different in different companies, right? But this is one of the ways it could work. Like first, you could inspire them with technology. You can show them some new stuff, explain how it works. You could build proof of concepts for that. So something that is functional, works with few examples. Then some natural way of developing things would be building a pilot project, showcasing functionality, and in the end making this production full-blown solution for them. When you introduce some new features, not bug fixes, you will probably have to go through this process again, like especially if those features are a bit more complex, not just we are adding one button to open the new report or something, but you want to bring them this power of technology. Often people are not aware what technology is capable to do, and that's why we need to inspire them always and show them what's possible to do. And we would go through this project again, show through this process again, show them like what can be done, proof of concept, bring it all the way to the production. So for this, like when we talk about Azure and AI, we talk about Azure Cognitive Services, of course. And I find them super easy to build a proof of concepts with examples you have over there, like really great and simple examples that you can use actually to showcase your clients what technology can do nowadays, and then build on top of that into something more complex. So, as Microsoft says, Azure Cognitive Services, comprehensive family of AI services and cognitive APIs that help you build intelligent apps. So we have decision language, speak, and vision. Web search is currently being moved out of Azure Cognitive Services. It was part of it. With decision, yeah, make smarter decisions faster. Language, extract meaning from unstructured text. Speech, this speech to processing, you are able to integrate into your applications and services. And we have vision to identify and analyze content within images and videos. So we will focus today to speech to text. If you remember our example, we have those salespersons on the phone talking and selling. They are sitting in front of the screen. They are entering some order over there into their system and trying to figure out like what is meaningful. So speech service features that accurately convert spoken audio to text. So text that is spoken, audio that is spoken converts to text, works with more than 85 languages and variants. Demo we did this project. I will show you demo we prepared. It was done in Swedish, and yeah, as far as Kim can say, it worked pretty well, right, Kim?
Absolutely.
Yeah. Yeah, I'm in Sweden only 2 years. My level of Swedish is not so great. I had problems ordering apples, but okay. So what also it allows you, speech to text, is to customize models, to make them be more accurate, and especially for this domain specific terminology. So if you're introducing some terminology that is new, product names, something like that, you can do that, and you can get more value from spoken audio by enabling search or analytics on transcribed text, or facilitating action, all in your performed programming languages. So yeah, features: high quality transcription, customizable models, flexible deployment, production ready. Great service. We'll start with a simple application, that is in React, and basically gives you ability to try out this service. Really super simple. What you need to do is go to this GitHub link, just clone it, and run npm install, and basically that's it. You get it installed on your computer. You will need to edit n file. So over there, you need to enter the speech key and the speech region. So in the Azure cloud, you need to go to your Azure cloud, use the speech service, and over there you should create it, and you get these values. You add this file and enter the values over here. When you make npm run dev, so you are running this React application, one browser window will pop up, and you will see the speech simple application that gives you two options. One is to convert speech to text from your microphone. The other one is to convert speech to text from audio file. So now you could press the microphone, and you say some sentence, and that sentence will appear on the right side, where at the moment you see this placeholder message, ready to test speech. And basically that is super easy example to run. And if you take a look at the code, that is also really easy to understand. And we are looking here at this parts of the relevant code. We have some recognizer. We are defining the variable display text, and then if we have this result, which is the recognized speech, we are putting on our I'll go here in the right box when you see initialized, so that display text goes over there. We are putting recognized, and then we are saying text equal this recognized text. In case something goes wrong, we show this error, speech was canceled or could not be recognized. Probably, yeah, microphone not working properly, or something went wrong. And yeah, in next few lines of code, we just set the state of display text. So once we pronounce the text, if it's get recognized, we are displaying this text. We got this text in our display text variable. What it means is basically that we can use this variable and figure out something else with that text, like maybe use it to make another query to show some relevant data and such. So yeah, also in the code you can find this speech configuration, and with property speech recognition language, which is at the moment set on English US. As I said, we were using it with Swedish works nicely. Personally, haven't tried other languages, but they say 85 supported works good. So you can try it out. And how to use this with real data, right? Let's now get to some more real stuff. We said we have this scenario where we have salespersons and they are selling the fruits, and those fruits have some names: apples, bananas, lemons. They have prices. They have some number of kilograms or number of pieces in the warehouse that we have at the moment, and some description and such. So over here, the thing is, we can query our existing system, and one person is on the phone and entering data, entering this order in one screen. On the second screen, or on the same, if you want to split it and put two views there, while person speaks, you can get the keywords out of the text and query your database to get some results out. And based on that query, you could build some logic on top of it, right? So what would logic be in this sales scenario? We need to figure out, like, okay, how many pieces we have actually in the warehouse, and what we identify. This is a real example. What happens there, out there, is that often such companies had a lot of order cancellations because they were selling the whole day, entering data into those orders. Then at the end of the day, they figured out, okay, but we don't have that many in our warehouse. So they spent a lot of time next day canceling those orders, right? And yeah, so you could figure out, okay, what is there, how many pieces needs to go. Food can spoil easily. Like, there is some period, okay, apples can be there for, I don't know, month 2. Bananas can be only a few days, right? So lemon can also be there longer. And you can build logic on top of that. And also there is this element, knowing your customers. So when you're making a query like about bananas, you're talking with him about bananas, maybe that customer previous year at the same time period was buying from you some other product. It's not easy to, your customers, but it's always nice to get reminded what was happening the year before and such. So this way you get these live suggestions, and those suggestions become smart when, based on those queries, you actually build the logic on top. So I will show you now the short demo video. And here is Kim, like, testing this system. Let's imagining she's at the moment on the phone, as you can see, and she will be. There's no audio in this video.
Thank
so
God.
she we would learn. Maybe they would learn some Swedish. Come on. So Kim is saying some conversation, right? And having conversation and mentioning some products, and they will pop up on the screen like suggestions. System is reminded her, offering different
Fruits.
different fruits from the warehouse, or what is over there. So you've seen that first there was
Apples.
short one. Yeah, there was popping up apples like conversation. Afterwards, they are popping the bananas. The thing is, when salesperson is making this conversation, like these suggestions give him idea, okay, maybe I can offer this next. And that's the way to increase the sales, right? It's not just the thing what should be gone that day, because that's how in those companies usually they have daily stand-ups, like, okay, we have too many bananas, they are gone in 2 days, we need to sell them, right? So everybody focus on bananas, but forget some other stuff, like, okay, that customer year ago was buying something else, or we are at the moment in the season of I don't know, watermelons or whatever, right? So this should be suggested at the moment, like, okay, we have this, we can sell this also. So something like regarding demand forecasting, how this is done. Microsoft AI platform provides this advanced analytics tool through Microsoft Azure, data ingestion, data storage, data processing, and advanced analytic components. So those are all of the essential elements for building demand forecasting. So on the left side, you can see the architecture overview, how this could look like. This is not something we came up with. This is from the recommended architectures, right? And what you have over here on the left, you have an event hub that collects real-time consumption data. Then you have stream analytics that aggregates the streaming data and makes it available for visualization. You have Azure SQL database that stores and transforms the consumption data. You have machine learning that implements and executes the forecasting model. And Power BI, it visualizes the real-time consumption and forecast result. And finally, Data Factory orchestrates and schedules the entire data flow. So this, for example, demand forecasting, how it can be done. This example was based on energy consumption. If you take a look at in the architecture best practices, but can be used elsewhere, right? Can be adjusted to your needs. And for example, over here with Power BI, we are doing this real-time, displaying the real-time consumption, what is happening, and we are forecasting results, what will happen in the future. And with this, we kind of got to the end what we prepared. I think we are a few minutes early, but yeah, hopefully we have some questions that we can answer. So I don't know, was there any to put it on the screen? Low cost.
Yes, we have one question here from Katarina. It's is it possible to start with an AI-driven solution without already having a mature business intelligence or data warehousing solution?
Yes. Why not? I would say, like, start building it, but for AI-driven solutions, like we need data, right? That's the most important. If we really want to get some real insights, real conclusion, then we need data. Is there something you would add to that?
Yeah, I think it's a very relevant question, because a lot of companies are getting stuck with not starting because they don't have all the foundations in the beginning. But I think it's important to find a way where you can start testing and making small proof of concepts, because that will also drive the initiatives to create the the data warehousing solution and so on. So if it's not in place, use these kind of examples to drive that discussion as well. I think with all these examples I showed earlier, we've had discussions with the client that, oh, we don't have this or we don't have that, or we have a data warehouse, but all the data is not in there and so on. But by showing small solutions, we can also show the value of what can be achieved, and that way it's also driving the data warehouse solution initiative, so to say. So I think it's important to move. Yeah.
I was saying that flow, you need to inspire the customers to get things going. So show them some small example. Okay, this is how things can be done. And like no need to do the over engineering and such. You've seen one simple example, what I show you through this presentation. Okay, this is the service, we can plug it in, we can quickly get some example, we can connect to the real data, and at first you will just return, okay, apples, no matter the order. After that, you slowly start the building logic and figuring out what is actually behind, what AI should be doing behind that business. So that's my take on it.
I think it's better to get going at least, instead of waiting for the best foundations and everything being laid out for you, because that's seldom going to happen.
Yeah, true.
Yeah, I also have a question here, because in this example you were using one of the cognitive services, speech to text, but have you also tried developing your own machine learning models?
Yeah, on top of data, that is done like in the background. So you, if you are asking me for natural language processing, no, because we are based in Sweden, both in Stockholm and Malmö, our offices, and as far as I know, there is still still a lot of research and effort put into the Swedish natural language processing models, like to get this accurate. And thing is, what Microsoft gives us, Azure gives us, comes out of the box, is super simple, right? And we didn't try to, we simplified completely, didn't try to figure out the whole sentences and whole questions. It's just trying to figure out the keywords and do triggers based on that. And for such things, it works perfectly. And my solution architect part of me is always, simplify until it's like, okay, cannot get any simpler than this. Then yeah, that's the way to do it.
Thank you. And one last question also, because you also mentioned the Microsoft patterns and practices, that this architecture that you had used, you had sort of just taken an already existing pattern. So what is your experience in using these patterns that are already published? Have you had?
Yeah, they are a great start to kick off conversation and such, especially with clients. Like you can pull it out in few minutes, and there's a lot of references there that you can easily apply or adjust or figure out, okay, this works in, I don't know, 80% of. And then yeah, through the conversation, you figure out the needs, figure out maybe, okay, how existing solutions look like, where data sources are, how you will connect that. And then you develop this through time. And of course, you don't land exactly there as it looks on the picture. But yeah, it develops over time. Yeah, but still, as a foundation, this is something that we should be aware that it exists, and especially if you do this solution architecture job, like yeah, that's your that's your main manual, like something to pull out immediately. Yeah. I hope this answers it. Yeah.
Okay.
We don't have any more questions right now, but Katrina also said, great way of looking at it that will help many customers. Thank you.
Yeah, thank
Thank
you,
you.
Catherine.
Good.
Yeah. Happy to hear some positive feedback that people found it interesting.
And we should also mention that Catherine is actually one of our speakers for this conference, and she will have her presentation tomorrow. So I hope that you will tune into that presentation too.
Yes, we will
Yes.
do
The
that.
second presentation, I think, at 6 o'clock.
Yep.
Yeah. Okay, that's great. Timing is actually good. In the afternoon, evening, people finish with work and then can watch. It's much easier, at least in my case. Yeah.
In mine as well.
Yeah. Cool.
Yes, yes. I think with that said, we can thank Goran and Kim for a really lovely presentation, and then before we leave here, I just have a couple of information here from the global Azure virtual that I'm just gonna share my screen here. One moment. So like this. So as maybe you know, this is part of a worldwide event. So if you want to have a learner badge, you can scan this QR code, and there is also a learn challenge. So you can go to aka.ms/global Azure 30D2L, which is 30 days to learn, and you can participate in a learning challenge. And then finally, they are also offering a virtual background as a digital swag, and also another badge for you if you go to the blog.globalazure.net/swag. So, Oddbjörn, I think we're through here for day one.
Yes, it was a lot of good presentations.
Yep.
Yeah. So great day, and I really can't wait for tomorrow.
No. So we hope we thank all of the speakers for today, and we also thank all of you, the audience, who have tuned in, or maybe you're watching this afterwards. And we hope that you will also come tomorrow, because we have a set of 4 great speakers tomorrow too. So thank you so much, and see you tomorrow.
Yes. Bye.